structural query language. What will you learn on the course? The course is a practical hands-on course. We'll start off by installing PostgreSQL. Then we'll learn how to load a sample database. We'll create a database. We'll create a table. We'll learn how to insert data into a table. We'll learn how to update existing records in a table. We'll learn how to delete records in a table. We will learn how to get data from multiple tables using table joins. We'll learn how to back up and restore database. We'll learn how to manage roles. We'll learn how to create table spaces. Also learn how to use various types of operators. We'll learn how to use aggregate and analytic functions, and we'll learn how to use views and triggers. So these are some of the stuff you will learn. Welcome to this lecture. What is PostgreSQL? PostgreSQL is also pronounced as Postgres. So if you hear people saying Postgres, they mean PostgreSQL. This basically is a relational database management system, just like Oracle or Microsoft SQL Server, or things like MySQL or MySQL. So it has basically the same features and functionalities of a relational database management system. It also complies to ANSI. ANSI basically is the American National Standard Institute for SQL, which is structural query language. So it also conforms to this standard. So the SQL you use for the Postgres database also follows the ANSI standard. So there are certain ways you write SQL statements that is applicable to all relational databases. Postgres is a general purpose database management system, so you can use it basically for a variety of things. It is also object relational, so it's known as an object relational database management system. It is free and open source. By open source, that means people can contribute to make it better. It is also platform independent. What that means is that you can install it on a Windows platform, Mac platform, a Unix platform. So it's platform independent. It's not pegged to one platform. So you can use it across multiple platforms. It is stable and requires minimum maintenance. So most applications that uses the Postgres database, you don't really need to spend a lot of time in the maintenance because the database itself is quite stable. The database has large storage. It also has a good performance. It's fast. It is extensible. Basically what that means is that you can define your own data types, index types. You can also create your own custom plugins. The support for the Postgres is quite substantial. There is an active community that you can post questions to and also receive answers from. So that is it for this lecture. The key thing here is to note that the Postgres database is a relational database management system, just like Oracle and Microsoft SQL Server. It is free and open source. It is platform independent. And the SQL you use to query the database also follows the ANSI standard. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be showing you a few companies that have built products solutions, websites, and tools using the Postgres database. I will start with the biopharm sector. So in the biopharm sector, we've got these few companies listed as using the Postgres database. So we've got companies like American Chemical Society, BASF, Agricultural Product Division, and we've got the Greenet Tech Inc. So these are just a few companies listed as using the Postgres database in the biopharm sector. Next, let's have a look at the e-commerce sector and see who's using the Postgres database. So we've got companies like CD Baby, Champion Products, Etsy.com. We've got Flight Aware, Flight Stats, Red Sheriff, whitepages.com. So these are companies listed as using the Postgres database. Next, we'll look at the education sector. In the education sector, we've got these institutions listed as using the Postgres database. All these information here have been obtained from the postgres.org website. So if you go to that website, look for featured users, you see all these listed there. Next, let's look at the finance and the gaming sector and see who is using the Postgres database. So in the finance, we've got 3 companies listed here. Among them is the Trust Commerce. In the gaming, we've got Moby Games listed as using the Postgres database. Next, we are going to have a look at who's using the Postgres database in the government sector. So in government, we've got all these listed as using the Postgres database. Among them are the City of Garden Grove, that's in California. We've got the National Weather Service. We've got United Nations Children's Fund. We've got the U.S. Agency for International Development, U.S. Department of Labor, U.S. General Services Administration, U.S. State Department. Some key government departments here using the Postgres database. Well, we're going to now move on to the healthcare sector, manufacturing, and see who's using the Postgres database. So in healthcare, we've got calorieking.com, and we've got things like Shannon Medical Center. Manufacturing, we've got exo2.net Corp using the Postgres database. And in the media sector, we've got a few listed here, among which are Macworld, Penny Arcade, the Washington Post, and the Greenpeace. Greenpeace is quite important here. I mean, it's well known, so to know that they use Postgres is interesting. Next, we'll move on to open source projects. There are some open source projects that actually use the Postgres database. So in the open source projects area, we've got things like Debian, FreshPorts, GForge, the LAMP. LAMP basically is a LAMP stack, which includes Linux, Apache, PHP, and a few others. And we've got the SourceForge as well, which is quite popular for various types of downloads. So they also use the Postgres database. So next, we'll look at the retail sector. We've got a few listed here in the retail sector, things like Safeway, Sutaya, the Rockport Company, among a few. They are listed as using the Postgres database. Let's move on to technology. We've got Apple, Fujitsu, Omnity, Red Hat, Cyrus IT, Sun Microsystem, among others, using the Postgres database. Also some telecom companies as well. Among the telecom companies using the Postgres, we've got Cisco, Juniper Networks, NTT Data, Optus, Rambler Internet Holdings, Skype, and Telstra. So these are the telecoms companies listed on the Postgres website as using their product or using the Postgres database. So that's it for this lecture. In this lecture, we went through a list from various sectors of various types of companies that actually have created products around the Postgres database. If you want to find out more, just head over to postgres.org and /featured users. That will give you a list of who's using the Postgres database. Most of what I've shown you here in this lecture was actually obtained from the Postgres website. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be showing you some minimum requirements that has to be met before PostgreSQL can be installed on your computer. So these are the minimum requirements, regardless whether you are using, if you're using a Windows, a Linux, or a Mac. So these are the operating systems that you can install PostgreSQL if you are on a Windows. So it doesn't matter if you're on a 32-bit or a 64-bit Windows operating system. This B here basically means bit. I just left out the I and the T to create some space. So if you've got Windows 7, 8, or 10, then your machine should be ready to accept the installation. Also, if you have Windows 2008 server, Windows 2012 server, you need a minimum of 1 gigahertz of processor speed. This is just the absolute minimum. You need at least 1 gigabyte of RAM. You need at least a gigabyte of hard disk space. You need an account that has an administrator role that you can use to perform the installation. However, if you've got an account that's got an admin role or privilege, you can usually right click on the installation file and select run as admin. For Linux, if you are running a Linux 32 or 64-bit, these are the operating systems you can use. You can use a CentOS 6.x and 7, Ubuntu 14.04, Debian 7 and 8, Oracle Enterprise Linux 6 and 7, and again, a minimum of 1 gigahertz processor speed is required, 1 gigabyte RAM. You need to have a super user privilege on an account. You need that before you can perform the installation. If you are on a Mac, you can install PostgreSQL on OS X Server 10.8, 10.9, and 10.10. You need a minimum 1 gigahertz processor power or speed, 1 gigabyte RAM or memory. You also need a super user account with super user privileges to perform the installation. So these are the bare minimum requirements if you're running Windows, Linux, or Mac and you wish to install PostgreSQL. These are the absolutely bare minimum requirements. So that is it. Thanks for watching. Bye for now. Hello there. In this video, I'll be showing you how to install PostgreSQL on your local system. Postgres was developed for Unix-like platforms. However, it has been designed to be portable, What that means is that it can run on multiple platforms such as Mac OS, Solaris, and Windows. I will be illustrating by installing Postgres on a Windows-based platform. Let's take a look at the steps that we are going to follow to complete the installation of PostgreSQL. So we are going to start off by downloading PostgreSQL installer for Windows. If you're installing on Windows, you do that via an installer. So once we've downloaded it, we'll then install PostgreSQL and we'll then verify the installation. If you are running Windows 8 or Windows 10, you will need to install PostgreSQL on an account that has administrative privileges. So let's begin by downloading the PostgreSQL installer for Windows, and the link is displayed on the screen. So if you head over to that link, and then we can begin the download of the installer. So once you've navigated to the installer download page, there is a link that says download the installer certified by Enterprise DB for all supported PostgreSQL versions. So click on the link and select. There should be an option here for cookies. You can click OK to agree, and then you select your version. Select the latest version that you can see. The latest version is usually displayed on top. As of the time of recording this video, the version is 10.5, so I'm going to click on that. And next you got to select your operating system. So I'm going to click on the drop down and select my operating system. I am running a Windows 64-bit, so I click on that, and then you have the link to download. So just click on the download now and it will begin the download. So that's my download there. It has started. I just give it a few minutes to complete the download. So the download has finished. So I'm just going to double click on the link here to run the installation. You may get a user account control pop-up if you're running a Windows operating system. Just click yes to accept that, and that will allow the installation to begin. So the installation is being processed at the moment. So we just let it go through the steps for processing and initializing the application. You'll be presented with a setup wizard. So click on next, and you are presented with a default installation directory. You can accept that, or you can specify your own installation directory. I would recommend you accept the suggested location that Postgres has specified. Just click next, and then you have this select component option. So make sure you accept all the boxes that have been checked. What that means is that it will install all the options here checked: PostgreSQL Server, the pgadmin 4, Stack Builder, command line tool. Just accept all and click next, and it tells you a data directory. It has specified a data directory for you. You can either change that or accept the default. I would accept the default. Click next. Next, you are given an option for a password. So you have to provide a password for the database super user for the Postgres database. So specify a password that you can remember. So this password here that you're setting up now is going to be the password for the database super user and service account. So once you've set that up, click on next, and it's specified a port. Please select the port number the server should listen to. The server has to listen to a specific port, so you have to specify one. By default, a port 5432 has been suggested for you. Please leave it as the default port and click next, and then you are asked for a database cluster if you want to set up a cluster. I would advise you leave the default, which is default local. Leave that as the default and just click next. Click next again, and then click next again, and we just wait for the installation to run through. The installation may take a few minutes to complete. The installation has now completed. You can uncheck this box here for the stack builder. The stack builder basically can be used to download and install additional tools, which includes drivers and applications that will complement your PostgreSQL installation. So I've unchecked that because that is not necessary at this stage. When you're done, just click on the finish button. Let's verify the installation. There are several ways to verify the installation. For example, you can try to connect to the PostgreSQL database server from any client application, for example, PSQL or pgadmin. However, the quickest way to verify the installation is through the pgadmin application. So let me show you how to access that. To access the pgadmin application, you do that from the programs menu and you click on the PostgreSQL folder. I'm just going to click to expand that, and within that we've got this pgadmin 4, which is an administrative tool for administering PostgreSQL database and its various objects. So click on that to launch it. The pg4 is an admin tool for managing PostgreSQL. So let's under this browser here, let's click on the plus sign, and under servers we've got PostgreSQL 10. Click on that, and it's trying to connect to the server. It says you're currently running version 3.2 of pgadmin. However, the current version is 3.3. Please click here for more information if you want to do that. So let's expand the server. You can click to update it if you wish, but I'm just going to exit out of that for now. And you can notice here it's giving you option to enter the password. So this would have been the password that you would have entered when you were trying to run during the installation process. So if you enter that password in there, it should let you connect to the server. You've got the option to save, but for security reasons, I don't think that's a good practice. So once you've entered that, click OK. And it says, you can see here on the bottom here, it says server connected, which means you have successfully connected and verified the installation. Once you have connected, and if everything is fine, the pgadmin will display all the objects that belongs to the server. So if I expand where it's called databases, you'll be able to see all the various objects that belongs to the server. You can see all these are all objects, and we're able to verify that because the installation has been a success. To see the properties of each of the objects here, you can just click on the object. For example, if I click on databases, you can see it shows that this is a Postgres database. The owner is this, and then you can click on other objects as well, login groups, and so on. So that concludes the installation of PostgreSQL. So congratulations if you have successfully installed the PostgreSQL database server on your local system. If you had any problem during the installation, please feel free to let me know. I'll do my best to help. Thanks for watching, and bye for now. Hello there. In this video, I will be showing you a couple of ways to connect to a PostgreSQL database. The first is via an interactive SQL shell, which is a terminal. It's called PSQL. And the second option is by a GUI. GUI basically is a graphical user interface using the PG admin tool. Let's try and connect to a PostgreSQL database using the PSQL tool. The PSQL is an interactive terminal program provided by PostgreSQL, so you can do a lot with it. For example, you can execute SQL statements, you can manage database objects, and so on. So let's try and play around with the tool and connect to the database. The first thing we need to do is launch the PSQL program, and you launch that from the PostgreSQL folder. So if you expand the folder and if you scroll down, you should see the SQL shell, which is PSQL. So if you click to launch the shell, so this is the shell. So the first thing you need to do basically is provide answers in different steps just by pressing tab or enter on your keyboard. So if you press enter, it will give you the name of the database. You press enter again, it will give you the port it is listening to. You press enter again, it will give you the username. Press enter and it will prompt you for a password. So you enter the password that you specified during the installation of PostgreSQL. Once you enter the password, if it's correct, it will give you this screen, and you can see you've got the hash symbol next to the Postgres, which means it is waiting for some instructions. So what I'm going to do, I'm going to type in a very simple SQL statement to determine the version of PostgreSQL. So you just type in select and then you do a space, type in version. So make sure you wrap the version number in parentheses, opening and closing, and then you terminate it with a semicolon. Press enter. It will give you the version. So you can see here, this simple statement has given me the version of PostgreSQL. So you can see from here, this statement has returned one row. So we've successfully connected to the PostgreSQL database. To exit out of the program, all you need to do is hit Ctrl and C, and you will get a prompt asking you to terminate. Just hit yes and press enter, and that will terminate the program. So let's take a look at a second method we can use to connect to a PostgreSQL database using the PG admin tool. This tool is a GUI application. That means it is a graphical user interface that you can see things in a graphical way. To access the PG admin tool, you need to open up the PostgreSQL folder by expanding it, and you should see the PG admin 4 tool. Just click to launch the tool. It's an administrative tool, so give it a few minutes to fully launch. So this is what the PG admin tool looks like. When you launch it, you have to select an object in the tree view. This is the tree view. So you click on the plus to expand it. You can see a red cross there, which means you have not connected to the server. So if you just click on it, it will give you this pop-up box to enter your password to connect to the server. If you don't want to enter the password each time, you could click on save, but I wouldn't recommend that. It's not really a good practice, although it's okay if you're working in your own environment, but it's good to develop good practices right from the start. So I'm not going to save the password. I'm just going to enter the password I entered during the installation of the database. So I'll click OK, and you can see here it tells me the server is connected. So I can now access the database objects. You can see if I expand that, you can see all the various objects belonging to the database. We can quickly run a very basic query to test that we can communicate with the database. So in this view tree here, under databases, make sure you've got the Postgres database selected, and then under tools, click on the query tool. The query tool is where you'll execute your query. So let's type in a simple query. So I'll do select, I'll do a space, I'll type in version, and then wrap it round parentheses, and then I will add a semicolon. So this, if you just press this here, this little symbol that looks like a lightning bolt, and that will execute the query for you. All right, so it has now executed the query. So if you put your mouse over the output here, you can see the output that was returned, which is this text displayed there. So we've successfully been able to determine the version of the Postgres database from a very simple query. To exit the PGAdmin tool, you just click on the X and it will ask you a prompt. Are you sure you want to leave? Just say leave, and that exits the application. You can also connect to a PostgreSQL database from other applications. So any applications that supports the ODBC driver or the JDBC driver can be used to connect to a Postgres database server. In addition, if you develop an application that uses an appropriate driver, the application can connect to the PostgreSQL database server using that driver. So let me quickly explain what ODBC and JDBC is. ODBC stands for Open Database Connectivity. It is an open standard application programming interface, which is API, that is used for accessing a database. JDBC stands for Java Database Connectivity, which is an application programming interface as well, API, for programming language Java. There's a programming language called Java. So it defines how a client can access a database. So it's basically a Java-based data access technology used for Java database connectivity. In this video, you have learned how to connect to Postgres database server by using different client tools, which included PSQL and PGAdmin tool. Okay, I also briefly introduce you to ODBC and JDBC. So these are APIs that can be used to connect to Postgres database from other applications. Thanks for watching and bye for now. Hello there. In this video, we are going to download and load a sample PostgreSQL database. I have already downloaded the database for simplicity, and the database is basically in a zipped format. So I've got the database in a folder here, so I'm just going to click on it. So this is the database. It will be available for you to download under the resource area for this lecture. It's in a zipped format, so you need to have a software extraction tool to extract the database. So you can use WinRAR, you can use WinZip, or any software extraction tool you have available. You can use that to extract the database content. So let me walk you through the steps we are going to take to download and load the sample PostgreSQL database. So we're going to start off by extracting the zipped database. We're going to extract it to a .tar format. Once we've done that, we're going to create a folder on the C drive or any drive you wish, and then we'll place the extracted tar format into that folder, and we will create a new database using the PSQL tool. We need to create a database to restore the sample database into. Once we've created a new database, we'll then have to load that sample database using a command line tool. If you're on Windows, you use the command prompt. If you're on a Mac, you can use the terminal. Once we've loaded that, we'll then verify the loaded sample database by running just a basic query to make sure everything works. So let's begin by extracting the database. I'm just going to click on this folder here, and the software extraction tool I have is called WinRAR, which is actually free to use. So I'm just going to right click and click on extract here, and it will extract the content. You can see now it has extracted the content. You can see this is the extracted content. If I right click and click on properties, you can see that it is now a .tar format. All right. So what I need to do is now go into my C drive. Let me right click and copy this, and I'll quickly go to my C drive, and on my C drive I will create a folder called temp just by right clicking and going on folder, and I'll call this folder temp. And inside this temp folder, I'm just going to right click and paste the tar formatted file. So this is the extracted database in the tar format. I've placed it into a folder on my C drive called temp. Next thing we need to do is create a database using the PSQL tool. So within the PostgreSQL folder, just click to expand that, and then click on the SQL shell, which is the PSQL. And what we need to do is create a new database. So just press enter to just provide some answers until you get the prompt to log in. All right, so we've got the username. And now you need to enter your password. So enter the password you entered during the installation of the database. Once you've entered the password, you need to create a new database, and the way you do that, you type in the command create, you do a space followed by the word database. Okay, you do a space followed by the name of the database, and the database is going to be called DVD rental. Okay, DVD rental, that is the name of the database. And then you end that with a semicolon. You press enter. You may get a prompt to enter the password. If you do get the prompt, just enter the password. If you don't get the prompt, it will return back to the command line, which means it has created the database. So once you get that create database, that means the database has now been created. The next thing we need to do is load the sample database from the temporary file that we extracted it to. So to do that, we need to open our command line tool if you're using Windows, or you can use the terminal if you are on a Mac. That's my command prompt. I'm just going to right click and click run as administrator, and that will open up a terminal window. So this is my command prompt here. So the first thing I want to do is just navigate to the C drive. So I'll do that by typing cd ... and that will navigate backwards. I'll do cd again ... and press enter, and that will give me the C drive. So I've now navigated to the C drive. The next thing I want to do is locate where my PostgreSQL was installed and add that to the path. So what I need to do is open up my folder and go to my programs menu and locate, it's usually in program files. So that's my PostgreSQL folder here. So I'm just going to click on that and then click inside that and then click in the bin. So this is what we want. So what you do, highlight this path here for the bin directly, just copy that, and then we go back into our command prompt, just type in cd, and then you paste the path into it and press enter. You can see now we are now referencing the bin directory from the Postgres installation. So I'm just going to type in CLS to clear the screen so that I only have the path I want. The next thing I want to do is to use the PGRestore tool to load data into the DVD rental database. So this is the tool here. I've pasted in this here. So you have PG_restore. You do the --U. That basically specifies Postgres user to log in to the PostgreSQL database. That's what that is. And then we have the DVD rental. Okay, and that is a path to the extracted sample database. So just press enter, and that will ask you for a password to the database. So you just enter the password to the server and press enter. You may get some errors. So if your console or your terminal is clear and it returns to this command here, that means it would have loaded the database. So if we launch the pgadmin GUI tool, we can use that to check the database that was loaded. So open up the GUI tool by locating it inside your PostgreSQL folder. So that's my PostgreSQL folder, and I'm just going to click on pgadmin4, and that's my pgadmin4 tool here. So this is the tool here. So it tells you here under databases is giving me 4 here. So if I expand that, I've already expanded it, you can see the DVD rental database. So if I expand that, you can see all the objects belonging to that database. If I come here and on the schemas, we've got the public schema, and these are all the objects of the schema. If I click here, you can see the tables. These are all the tables. There are 15 tables in this sample database. So if I want, I can do a quick test by going on the tools here and opening the query window. It's saying no object selected. I need to select an object. So I select the schema and come here and do query, and it will reference that schema. You can see here it's got DVD rental. That means it's referencing that database. So I should be able to execute a query against any of the database tables. So I'm just going to pick this table called actor. So I will type in select and star from the table called actor. I'm using the asterisk because I want it to select to return all the records from that table. I then press this symbol here, and you can see the output here. It tells me successfully it has returned 200 rows from this table. So this is a verification that we have successfully loaded the sample database. In this video, we downloaded and loaded a sample PostgreSQL database. We started off by extracting the zipped database into a .tar format. We created a temp folder on the C drive and placed the extracted tar format into that database. We then created a new database in PostgreSQL using PSQL. You have to create a database in order to load the sample database into. So we did that. We then loaded the sample database using the command line tool, and we were able to verify the loaded sample database by running a very basic query on one of the tables in the database. Thanks for watching. If you had any problems during the loading of the database, please feel free to contact me. I'll be more than happy to help. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will be showing you how to download the latest version of PostgreSQL for Windows. We are going to be downloading the latest version for Windows. We are going to head over to this link here to begin the download. https://www.postgresql.org. So let's head over to that location. So this is the site for PostgreSQL. So once you're here, make sure you're on the download page by clicking on this download button. And once you've clicked on the download button, it will give you various options. We are interested in the Windows option, so we're going to click on Windows. Click Windows, and that will give you this page. We want to download the installer to make it easier for us, so click download the installer, and that will take you to the installer page. And the first thing you need to do is select your version. We want to use the latest, so I'm going to click on the drop down, and this is the latest, so I'm going to click 9.6.2. The next thing we need to do is select our operating system. So I am running Windows, so I'm just going to select this, and it will be Windows x86 followed by your bit. If you're running 32, you click 32. If you're running 64, you click on this Windows x86-64. I'm running 32, so I'm going to click on this option. If you're not sure if you're running 32 or 64 bit, the way you find out is go to your start menu, right click on my computer, go properties, and there's an option here that says system type. Within the system type, it will tell you if it's a 32-bit or 64-bit operating system. So I've already made my selection, which is a 32-bit. So I'm going to click download now. So I'm just wait for a few minutes for the download to start. So that's my download. It has started. It is 156 megabyte in size. So please make sure you've got enough space on your disk to accommodate this file. The download as completed. So if I click on this little arrow here and click show in folder, it will take me to the location of the downloaded file. So my file has been downloaded into my downloads directory. So in the next lecture, this is where I'm going to install the software from. So that is it for this lecture. In this lecture, we learned how to download PostgreSQL for Windows. Many thanks for your patience and thanks for watching. Bye. Hello and welcome. In this lecture, I will be showing you how to install PostgreSQL for Windows. Please note that if you are running Windows 8 or Windows 10, you will need to create a Windows user account that has administrator role or privilege. You then need to use that user account you've created to run the installation. For example, you can create an account for the installation called Postgres and make sure it's got local admin privileges and use that account to run the PostgreSQL installation files. I will be installing on a Windows 7 machine, so I don't need to create a special account for that. So locate your downloaded files. Mine was saved to my download folder, which is this folder here. So all I need to do is just run the installation. So I just right click on the file and select run as administrator to begin the installation process. So it will initialize the files, which can take a while. The processing power on your local computer basically will determine how long the installation will take. But on an average, it takes more than 5-10 minutes. So once you're done, you should get, once it's initialized, you should get this screen come up. Click on next. You are presented with an installation directory and there is a suggestive location here. I would recommend you accept that. If you don't want that, you can click here and select a location where you want it installed, but I will strongly advise you just accept it, especially as this is a test environment. Click next. Again, you're prompted for a location for the data directory. A location has been put in there for you. You can accept that or select your own. I will advise you accept the location that has been suggested for you. Click on next. This is important. You need to enter a password and also retype the password. This password you will need to enter each time you try to connect to the database. Very important you enter a password that you can remember. I have entered the password and I've also retyped the password. So enter one you can remember and click next. This is auto-populated. If you've already got the PostgreSQL installed, then that may be the reason why this is not populated, because it tends to use this port number. So if you haven't got it installed and this port number is not available, then you need to do some troubleshooting, because this port has to be available for PostgreSQL. So this is usually auto-populated for you. Click on the next button. Again, this should be auto-populated. Accept the default locale. Click next. It says setup is now ready to begin installing PostgreSQL on your computer. Click next. And this process can take a few minutes, again depending on the processing power of your local computer, so please be patient. Once the installation is complete, you will get a screen like this come up. You can uncheck this. This stack builder basically enables you to install other stuff that you may need for the PostgreSQL installation. But because this is a test environment, I'll just uncheck that and click finish. So we have successfully completed the installation of PostgreSQL. Thank you for your time, and bye for now. Hello and welcome. In this lecture, I'm going to show you how you can verify the PostgreSQL installation for Windows. So a very quick way to verify the installation is just to see if we can access the default database. So click on your start menu, click all programs, and within the all program there should be one for Postgres. So look for the PostgreSQL 9.6 folder, click to expand it, and click to open up pgadmin 4. That is the admin console that you can use to administer the PostgreSQL database. Please be patient. This can sometimes take a little while to open up. Okay, so mine is just about to open up now. When the pgadmin 4 tool opens up, this is what you'll see. So to verify the installation was successful, we should be able to connect to the servers. So click on this plus button here to expand it. If you can see this, if you can expand it, that means the installation has been successful. However, if you click on this plus sign here, it will give you a window asking for your password. This will be the password that you set during the installation. So just enter that password in there, and then you can click OK. You can save the password if you wish, but I don't recommend it, so that you don't form a habit of doing that. That can be a security risk in a production environment. But if you're on a test environment, it doesn't really matter, but it's good to cultivate good habits even if it's a test environment. Once you've entered your password, click OK, and if it works okay, you should get a different screen here. So this is the dashboard. You should get a message that pops up to tell you that you have connected to the server. That briefly pops up, then disappears. So this is a server. So if you can expand the databases, and this is a default database that was added. It tells you here databases 1. So if you can expand that, that means the installation has been verified and successful, because you can access aspects of the database. So while you've got the databases selected, you can flick through different aspects here. This is a dashboard area. You can click on the properties. It shows you a different view for the properties. It tells you the name of the database and give you some other information there. And if you click on the SQL here, it gives you the SQL that was used to create the database. If we click on statistics, again give you different views here, so you can read through, and then click on dependencies. If there's any dependencies, it will show the dependencies. So let me just click on the dashboard. So if you can access all these and move things around, your installation has been successful and verified. So that's it for this lecture. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I am going to do my best to guide you as to how you can install PostgreSQL on a Mac. I haven't got a Mac to show you, but I will do my best to guide you as to how you can do this. The installation should be slightly different just because of the format. However, you'll be using the same graphical user tool that I used to show you the installation on a Windows-based computer. So we're going to start by going to the website. So the website is https://www.postgresql.org. So we're going to head over there to download the file. So this is the home page for the PostgreSQL. So if you click on this download tab here, you will have different options. So if you are on a Mac, you need to click on the Mac OS, click on that option. And then what you need to download the installer. You see this option here that says download the installer. This is what you need. So click on that and that will take you to the installer page. So where you've got select your version, you select the version of your Mac. For example, if the version of the PostgreSQL, so select the latest version, which is usually at the top. So select that one. And then for your operating system, click on the drop down arrow and select, there's only one option for Mac, just select Mac OS X. And then there's an option to download. So you can click on the download and that should download to your Mac folder or download that. I've just clicked on the download even though I'm not on a Mac, and this is the file. So it packages it as a DMG file, which is a disk image file. So to extract the installer, you basically simply have to mount the disk image and copy the installer to the desired location, or you can run it directly from the disk image. Please note that by default, Mac OS X ships with shared memory settings that might be too low for running the PostgreSQL. However, the installer will detect this and if possible reconfigure the shared memory and then may prompt you to reboot the system and rerun the installation. So if you get that happen, don't be surprised. So that's basically it. So just run this DMG file and just follow the screen instructions. So that's it. Thanks for watching. Any issues, please let me know. Bye for now. Hello and welcome. In this lecture, I will show you different ways to connect to a PostgreSQL database. You can connect using an interactive terminal program, which is also the shell, the SQL shell, or also known as PSQL, or you can use the graphical tool, which is known as pgadmin. So that is a graphical admin tool. So those are the two ways you can connect to a PostgreSQL database. So both the SQL shell, which houses the PSQL, and the pgadmin GUI are installed when the Postgres database is installed. So let's go over to our program menu and explore both options of connecting to the data. To launch PSQL, you click on the start menu, go to all programs, click on the PostgreSQL 9.6 folder, click to expand, and this is the SQL shell which houses the PSQL. So click to launch, and when you open it, this is what you get. If you press enter, it will also add the database name. This shows you that the server is localhost, so it's a local installation. So press enter, it will give you the database. So it tells you the database name is Postgres. That's the default database that comes pre-installed when PostgreSQL is installed. If you press enter again, it will give you the port number, which is 5432. And if you press enter, it will give you the username that is used to connect to the database. So this is the username called Postgres. If you press enter, it will prompt you for a password. The password it's asking for is the password you would have set during the installation of the database. So just type that password in. So I'm just going to type mine and press enter. If it is right, it will connect to the database, and you get this warning here with some instructions here saying blah blah blah. But if you can see this flashing cursor, it means that you have successfully connected to the database, and this means the database is just waiting for some instructions. So as it is, you can execute a SQL query. Once you've got that flashing cursor there. So that's how you connect to the database using the SQL shell or the PSQL. So I'm just going to exit out of that. The second option is to use the pgadmin tool. This is also located in the same directory as the SQL shell. So click on Start or Programs, go to Postgres, click on that, and this is what we want, pgadmin 4. That's the current version. If you click on that, it will launch the pgadmin tool, and the latest version of that tool is version 4. Please be patient with this tool. It can sometimes take a while to open up. Once the tool opens up, we can connect to the database by expanding the servers here where it's got servers. Click on the plus sign to expand, and you've got the PostgreSQL 9.6. So click on that. It will give you an option to enter your password. So I'm just going to click expand that. There you go. So this should pop up. It says connect to server, and the username it's using to connect is Postgres. So you need to type in the password you set during the installation. So I'm just going to pop my password in there and click OK. And if everything checks out, you can see here it says server connected. Once you're connected, it tells you you are connected, and we can now access the database. So these are at the moment we've only got one database. That's why it's got one there, which is the default database installed with the PostgreSQL database, which is this one here. That's our default database. So basically those are the two main ways you can connect to a PostgreSQL database. Another way to actually interrogate or interact with the database is via the query. So if we click on the tools here and go to select the database first, make sure you got the database selected, and then click on tools and click on the query tool, and that should bring up the query editor. So just write a simple query that will interact with the database. So you just type in select followed by the version. You're looking for the version, and then parentheses and a semicolon, and then you click on this arrow there to execute the query, and it will show the result in the output here. So this is the output for the query. It tells you the version is PostgreSQL 9.6 and give you some information about the build and so on. So this tells you you can expand this. By the way, you can see I've just dragged it to expand it along to reveal more information. So it gives you the version and tells you it's compiled by Visual C++ and the rest of it. So that's one way of also interacting with the database. So thank you so much for watching. In this lecture, we've learned how to connect to PostgreSQL database server by using different methods. Thanks for watching and bye for now. Hello and welcome. In this lecture, I'll be showing you how to load a sample database into PostgreSQL. The sample database we are going to use is called the DVD rental database. This is a sample database taken from the Sakila sample database from the MySQL site. So this is the database I'm referring to. So basically I made some slight modifications to it to make things a lot easier for you. It's called a DVD rental. I've already extracted it here. So this is the extraction. This will be included in the resource page for this lecture. So you can just download it and follow along. This database should be more than enough for us to learn and practice using PostgreSQL. The database itself contains many objects. It has 15 tables, 1 trigger, 7 views, 8 functions, 1 domain. It also has 13 sequences. So once you've got the file downloaded, this file here, which is going to be available for you to download inside your resource page for this lecture. Once you've got that downloaded, what I need you to do is go to your local drive and say your local C drive if you're on a Windows, okay, and create a temp folder. So create a folder called temp, as I've done here, and add that file to it. So on your C drive, make sure you have a folder called temp and just add the DVD rental zipped or extracted file, the actual compressed file. Don't extract it, just make sure you add the compressed file into that temp directory. You can see 2 other files. These are not related to this lectures. These are other files that I can delete this actually because they're not related to this course. So you should only have this compressed file called DVD rental inside the temp directory, which is housed in the root of the C drive. Once you've got that done, launch the admin tool, which is I've already got it open here, which is the PG admin tool. You can launch that from the all programs, go to PostgreSQL and click on PG admin 4. So I've already got the tool selected. Make sure you've got the next thing we need to do, because we are going to load a database, we need to create a new database. So to do that, you right click on where it's got databases and go create database. So we are going to create a new database called DVD rental. So we need to give the database a name. I'm just going to call it DVD rental. I've got it all in lowercase, but it's up to you, it doesn't really matter. And the owner will be this user here called Postgres. And then in the comment, you can say whatever you want. I'll just say DVD rentals. Okay, and just click save. And by clicking save, that should install the database. So if I right click and refresh this now, this figure should change. You see it's already changed to 2, which means we have now successfully created a database called DVD rental. Now we can load the sample database. To do that, you just right click on where it says DVD rental, right click on that, and there's an option to restore. Click on restore. All right, you get this saying please configure the PostgreSQL binary path. All right, so what we need to do is configure the path for that. So click OK and click on your file option, go to preferences and look for path. This is what it's complaining about. Under path, click on binary path, and inside the binary path we need to go to where we installed the software. So we installed in program files, and there should be, click on Postgres and click inside that folder, click on the bin directory and click to get the path. So this is the path is asking for. Copy that and paste it in there and say OK. If it's happy with that, there should be no complaint. So what you need to do now, we can go back and restore the database. So click on DVD rental, click on restore, and that error should no longer occur. Okay, format, select format is going to be custom or tar. Click on that. File name, we need to select where it is, the location. These 3 dots here gives you, enables you to browse the location of where the files are. Okay, alternatively you can manually insert the location of the file. So we're just going to go to where we've got the file stored. Is in a temp folder, this temp folder here, because sometimes it's slow. Now it's opened up, sometimes that can be slow to open. So we click on that, the C drive, and it's inside the temp folder. It says it can't find any files. Okay, so I'm going to click cancel. Sometimes it can have problem locating the files. So I'm just going to go manually and get the location, which is in the temp folder, DVD rental, and then just cancel out of that. If you click, all you need to do is just do a slash and add DVD rental. That's it. And just get the path from there, copy and paste it in here, and that should be it. You can leave the other option blank. Role name, you don't really need that. Or you can just select Postgres, which is the user that has the privilege to install the software. So click on this restore button here, and if everything goes to plan, it tells you here restore job created, restoring backup on the server, gives you all kinds of information regarding the backup. It tells you successfully completed. So we have successfully restored the database. So we can quickly check the database. This is the database here. If you click on this schema to expand it, the tables will be located inside the schema, and the name of the schema is public. Click to expand that, and then we can see all the objects for the database. So these are the tables. These are the trigger sequences. Let's focus on the tables here. Let's expand that. We should see 15 tables. It tells you there 15 tables. So we've got all our tables loaded. So we are good to go for the rest of the course. We've got our lab sorted, and we can progress with the rest of the course. So if you've successfully loaded the database, well done. If you've got any issues, please do not hesitate to let me know. Many thanks and bye for now. Hello and welcome to this lecture. In this lecture, we are going to look at the server service. When you install Postgres for the first time, you usually will have a corresponding Postgres server service. It is also referred to as the Postgres server. So let's open up our admin panel so we can take a look. So to open up the admin, go start and look for the Postgres server, the folder. So you see a folder here called Postgres 9.6. Click to expand and click to open the pgadmin4, and that will launch the admin panel. This can sometimes take a while to launch, but it shouldn't take too long, hopefully. So once the pgadmin opens, we can click on the plus sign here to expand the servers. So you can see the list of servers. So just expand that. And you are prompted for a password. So this will be the password set when you install the Postgres database. So type in the password. You get prompted for this password each time. If you don't want to get prompted, you can click to save, but that is not a good practice, especially in a production live environment. But if it's a test environment like we are doing now, you can do that, but it's good to cultivate good habits, regardless if you're in a live or test environment. So click OK, and that will give you access to all the databases and objects of the Postgres. So when you install an instance of Postgres, you also have a corresponding Postgres server service, which is also the Postgres server. So you can see the list of servers here. We've got the Postgres. This is actually the Postgres server. You can install multiple Postgres servers on a physical server using different ports and also having different locations to store the data. So it is possible to install multiple Postgres servers on a physical server, provided you use different ports and also store the data in different locations. So if you want to see more, just click on this Postgres here option here, and then click on properties, and you can see a more detailed view of the server service. So it gives you some information here, tells you the name, the server type, PostgreSQL, the version, gives you the version, and it tells you the port number it's installed to. 5432 is the default, and tells you connected, true. And let's have a look. And here maintenance tells you that, username, SSL mode, give you optional prefer. So these are some information you can access from the property option when you select the Postgres option here. And the server also has some databases here. So if I expand the databases here, you can see it's got 2 here, which means there are 2 databases listed. The one is called the DVD rental, which is a sample database that we loaded on. And this Postgres database is the default database that comes when you install an instance of the Postgres relational database system. So the key thing here in this lecture is to note that the Postgres server service is also known as the Postgres server, okay, which is this one here, and that comes installed when you install an instance of the Postgres relational database system. So that is it for this lecture on the server service. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we'll be exploring a database. A database basically is a container of other objects such as tables, views, functions, indexes, and so on. You can usually create as many databases as you want inside a Postgres server. So a database is a container of other objects, which includes objects like tables, views, functions, indexes, and other objects as well. So let's go over to our admin panel and have a look at the database and its related objects. I have already logged in to the pgadmin 4. If you are not logged in, you can log in via go to all programs and select the Postgres folder and then click to launch the pgadmin 4. Once you launch it and you try to access the database or the server, it will prompt you for a password. Just enter the password you set during the installation of the Postgres database. So the databases on this Postgres server at the moment are two. We've got this DVD rental that we loaded, and we've got the Postgres database. This comes built in when you install an instance of the Postgres server. It also installs a Postgres database. So what I'm going to do, I'm going to expand this DVD rental database so we can have a look at some of its related objects. So all these here are all related objects for a database in the Postgres server. So I'm just going to expand this here, the schema here. So within the schema, there is also the public. Let's expand that, and then we can take a look at some other related objects like a table. We've mentioned the table, so these are the tables for this database. If I expand that, you can see it says there are 15 tables for that database. And also you've got things like functions. You've got various types of functions for this. These are functions doing different things. We've also got sequences. So if if you're trying to add a record, you want them to be in sequence and so on. And then you've got views. Views are like tables, are like virtual tables. So these are all related objects of a database. So the database itself is a container of other objects. And these here, anything under this, this is the database. All these here are all container objects for the database. So that's basically what a database is. That's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. A table is basically used to store data for a database. So any data that is stored in a database is usually stored inside a table. In a database, you can create as many tables as possible. Open up your pgadmin 4 tool. I've already logged into mine, and I'm just going to explore some of the tables inside this DVD rental database. So I've got the DVD rental database expanded, and I'm just going to expand the schema. And from within the schema, we've got the public expanded, and there is some tables here. So I'm just going to expand the tables. So these are all the tables here for the DVD rental database. and data for a database is usually stored in table. What I'm going to do, I'm going to run a very quick query so you can see how the table data is structured. So I'm going to run a quick query to see all the columns and rows for this table here called actor. So to do that, I'm just going to right click and click on query tool. And the query tool is the tool you need. It's a built-in tool that you need to interrogate data from the database. So this is a tool here. So I'm just going to write a quick statement here. Do select. So I'm now using SQL to communicate with the database. I'm just select star meaning all from the database. The table is actor, and you have to put a semicolon at the end to indicate that's the end of the statement. So what this statement is saying is that I want to retrieve all the data that has been stored in this table here called actor. So if I click on this thing here that looks like a lightning bolt, and that will execute the statement, and it will show the output in this window here. So it tells you here the total query time, tells you the time it took basically. So this is the structure. So this is how a table stores data in columns and rows. So you can see the columns here going this way, and you can see the rows here. These are all the rows going vertically and the columns going horizontally. So you can see this is all the data from this table here called actor. By using the asterisk sign, it retrieves all the data from the columns and the rows relating to that table. So this is basically how a table stores its data in columns and rows. And a database stores all its data inside tables. They have various tables, and the tables also can have some relationship between each other. So we've got a table called actor. There may be some kind of relationship via one of the columns to other tables within the same database. So that is it for this lecture on tables. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a schema? A schema is a logical container of tables and other objects inside a database. Each Postgres database can have multiple schemas. A schema is useful in a production environment in that you can assign permissions to different IT professionals to perform various tasks within a specific schema. I have signed into the PG admin 4, and here on the database section, we've got a database called DVD rental. And if you notice here, we've got the schema. It says here there's only one schema, and that schema, you can see the symbol here, is a public schema. If I right click, we can look at the properties of that schema. It gives you the name, which is public, and tells you who owns the schema. And there's also a comment here. It tells you standard public schema, which means everyone has access to this schema. However, in a production environment, you can create several schemas, and within that schema, you can have various database objects inside that schema. For example, you can create a schema called finance and assign permissions to those who only work in the finance department. You don't really want to make that type of schema public for everyone to see because it contains sensitive information. for example, people's salaries and other financial related information. So schemas are quite important because you can use schema to group related objects and then just assign permissions to that schema. You could also have a schema, for example, for IT professionals, and as again, you assign specific permissions to those who can perform tasks within that. Even within a schema, you can still lock things down if you wish to. You can, for example, you can create a schema called finance, and within that finance schema, you can also lock certain tables or limit the access to certain tables from people who work in that finance department. But schemas are good in that they help, they act as a logical container to hold various database related objects. So that is it for this project on schema. Just know that the schema is a logical container that holds tables and other objects inside a database, and it is possible to assign permissions to schema so you can restrict who has access to the objects inside a schema. Many thanks for watching, and bye for now. Hello and welcome to this lecture. What is a table space? A table space is basically a storage location where the actual data that is underlying the database objects can be kept. It basically provides a layer of abstraction between the physical and the logical data, and also serves to allocate storage for all relational database managed segments. We know that data in a database is actually stored in tables. In the actual tables, they are actually stored in table spaces. By default, Postgres has two table spaces. The two default table spaces provided by Postgres when the relational database management system is installed are the PG default and the PG global. So these are used. The first one, which is the PG default, is used for storing users' data, this PG default, while the PG underscore global is used for storing system data. So PG underscore default stores users related data, and PG underscore global stores system related data. So we can take a look at the default table spaces. If you log into the PG admin 4, I've already logged in, but if you're not sure how to log in, just go to Start, All Programs, click on the Postgres folder, and just click to open the PG admin 4. Once you click on the database, it will prompt you for a password. Just enter the password you set during the installation. So let's have a look at the default table spaces. So under here, you've got table spaces. You can see there it's got two, which means there are two table spaces. These come as default when you install the Postgres server. So let me expand so you can see them. So you can see the first one is called PG underscore default. This is used to store user related data. So any data relating to the users is stored in this table space, while the second is PG underscore global. This table space stores any data relating to the system. So these two come as default when you install the Postgres server. So that is it for this lecture on table space. Thanks for watching. Bye for now. Hello and welcome to this lecture. What is a view? Views are basically virtual tables that are used to basically help simplify complex queries. They can also be used as a kind of security to protect certain records from others. So views basically are treated just like a table, so you can execute or run queries on a view just as you would on a table. You can use views to hide information or protect certain parts of a table from others to see. So you can create views from a table. The sample database, which is this DVD rental, has some views. So let's take a look at them. So we're going to expand the schema here. From the schema, if I scroll down, you see we've got 7 views here for that table, for that database. So if I click to expand, you can see these are different views. For example, we've also got if I look, notice here we've got a view called actor info. Let me click to expand that. So views basically have same characteristics as a table. So you've got columns and you can also have rows. Okay, so these are all so you can query, basically you can query a view just as you would a table. So let's quickly query this view here. We've got a view here called actor info. So let me right click and select the query tool, and it should launch the query tool shortly. And when it launches, I'm just going to quickly query this view. So you query them the same way you would query a table. So I'm going to just do a simple query here. Just select star. Star means I want all the rows and columns from that view to be returned. Select star from. You always have to use from to specify where the data is coming from. So the data is coming from the name of the view is called actor underscore info, and then place a semicolon at the end of the statement. So this is the name of the view here. If I execute it by pressing this here, it should give me an output here. Okay, so basically it tells me here 200 rows retrieved from this query. So it basically behaves the same way as a table. It's basically a virtual table. So you can run queries on views just as you would a table. If I click on this table, I've got tables here. I've also got a table called actor. Okay, and you see here I've got a view here called actor underscore info. So views are virtual tables, and they're quite useful in that you can use them to simplify complex queries. Okay, and also you can use them as a security measure to hide certain records from certain people or certain parts of the organization. So that's basically what views are. Many thanks for watching. Bye for now. Hello and welcome to this lecture on functions. What are functions? Functions in Postgres are basically a block of reusable SQL code. The code can also return a scalar value of a list of records. It also can return composite objects. Let's take a look at some functions that have been created inside our sample database. We've got a sample database here called DVD rental. So if I expand the schema, we can see inside the schema there are functions. So we've got 8 functions for this database. So let me expand that. And they do different things. So they're basically SQL code that can be reused over and over again. So these are all the various types of functions created for this sample database. So you can create your own functions as well. So let's have a look at one of them here. This one here says get_ customer balance. That's the name of the function. So to explore the function, I'm just going to right click on the properties of one of them. This one here that says get_ customer balance. And I go properties. And within the properties, we can have a look at several things. So let's start with the definition. So click on this definition tab. And if I just expand this, you can see more about the function, how the function was written. So you've got the arguments for the function, the types of arguments the function takes is in there. The type of value it returns, it tells you it's numeric. The language is PGSQL. And this is the actual code, okay, that generates the function or activates the function. So this is the actual code. These are basically SQL statements. So that is the definition. Let's look at the options here, what we've got in the options. All this estimated cost 100. Let's look at arguments. So you can look at different aspects of the function to see how it was created and what it does. So these are the data type. The data type is integer, which means it's a number. You've got timestamp without the time zone. You've got arguments p_ customer ID, p_ effective date. Let's look at the parameters. There's no parameters set. What about security? No obvious security issues here. Then look at the SQL. It tells you nothing has changed since it was created, so no modification has changed. So the SQL part of it has nothing new to explain because nothing has changed from the when it was defined. So I can just click cancel out of it. So you can do the same with the others, just to look through to see how it has been set up. So the key thing to take away basically is that a function is a reusable block of code. If there are specific tasks that you perform repetitively over time, you can build that into a function and just execute that function to perform that task. You can also delete a function as well by dropping them. For example, if you no longer need it, just right click and there's an option to delete or drop a function. And you can also create a function as well using this tab and using the create function tab. So different things you can do. You can create scripts from them. You can using the create script, or if you just want to read data, you can use the select script to extract SQL from the functions and just read data from the database. So several things you can do with a function tab. So that's basically it for this lecture on functions. Many thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, I'm going to explain what a cast and operators are in Postgres. I'll start with a cast. Cast basically enables you to convert one data type into another data type. When you perform conversions using cast, it's usually done in combination with functions. So you use functions in combination with cast to perform conversions. Postgres has default cast, but you can create your own custom cast that will override the default ones created by Postgres. Operators in Postgres basically is a symbolic function. So Postgres allows you to define custom operators. Looking at our sample database, we have an option for cast. As you can see, there is none at the moment, so no cast has been created. So if we had created a cast, this is where it will be. Also functions, also the operators are a kind of symbolic function. So if you need to create or define your own custom operators, you also can do them, and they will be housed within the schema. So you've got the functions tab here, so you can create your operator, which are a kind of symbolic function. So just to wrap up for this lecture, cast basically enables you to convert one data type into another data type, while operator is basically a symbolic function. So in Postgres, it allows you to define your own custom operators. When you are using cast for conversions, you use it in combination with functions. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'm going to briefly explain what sequences are. Sequences are used to manage auto increment columns. That is, columns that have auto increments on them. This is usually identified with ID columns, columns that have to be unique. We are going to look at our sample database and see the sequences that have been created for that database. Please log into your pgadmin 4. I've already logged in, and select the option for the sample database, which is DVD rental. Click on the plus sign to expand it. And if we expand it further, go to where the schemas are, expand the schema, and we should see the sequences. This database has 13 sequences. So let me expand that to see. So these are the various sequences that have been created for this database. So let me take a look at one of them so we can see how sequences actually works. Normally when you create sequences, you can see the naming convention. You have to name it with the underscore. You have to have a SEQ to indicate that it is a sequence. So let me click on this one here, the first one here, actor underscore actor ID sequence. So obviously there's a table here called actor, and that table, there's been a sequence created for that table. So I'm going to right click on this one here and select the properties. So if we go to the property, it tells you what the name of the sequence is. If we look at the definition, it tells you normally when you create a sequence, you have to set a maximum value. So here, this is a maximum value, and it tells you here, this is the current value for this sequence. So for example, if I was to insert another data into this into this table, and I use the ID, it will increase it by 1. So it will now turn that into 201. So it's a column that auto increases. So if I insert a record for, say, actor ID, it will automatically change that value to 201. So let's look at the security on that. Nothing special. Look at the SQL, nothing has changed. So I'm going to cancel that, and I'm going to see if I can create a script. If you want to create a sequence, this is the syntax. You just click on create sequence, and it gives you the option. You have to name the sequence, the owner, the schema, and then you have to define the sequence. You specify the increment. How is the sequence going to increase? Is it going to increase by 1, by 2, and so on? So these are all the parameters you set when you create a sequence. So I'm going to right click and go where it's got create script. I'm just going to create the script. This is a script that would generate for you if you want to create a sequence. So let me just break it down a bit so you can see. So this is what the sequence looks. This is basically how you create a sequence. This is the SQL for it. You start with the word create sequence, and then this public here indicates the schema, which is this schema here, and this here is the name of the sequence, okay, which is actor _ actor ID sequence. The sequence will increase by 1. So if you want to insert records into a table called actor, that sequence, the ID column will automatically increase to the next value. If, for example, the first record that you created has an ID of 1, the sequence will, when you create another record, the sequence will automatically give it an ID of 2, and so on. And this increment means it increases by 1. So if you add another record, that record will assume the next value. For example, if the record is 4, it will assume 5. The next added will be 6, and so on. Also here is, notice that it says start 200, which means that the current record for that table is 200. That means there are 200 records in that table. So if I was to add another record, it will increase by 1. That means the next record will now be 201. So there's an increment value, there's a minimum value, and this is the maximum value, which is the amount of sequences that can be created. This is the value of the, and then you have a cache. Normally you can have a sequence in cache and use that. All right, so it tells you who owns the sequence, and if you want to alter and make modifications, you can use the alter sequence command to make modifications. So this here basically is the query you use to create a sequence. So it's basically the same thing as when you write, if you do create sequence, and in the definition, all this here listed here is basically what this SQL is doing. Sequences are useful also in a live production environment. If you've got several people updating the same record or adding new records, you don't want the records to be out of sync. So by using a sequence for a column, when one adds a record, it automatically, attaches a sequence value and increases that record. So sequences are quite useful to keep records in sync. So that's it for this lecture on sequences. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be explaining briefly what the concept of extensions are in Postgres. Basically, in Postgres, extensions are used to wrap other objects into a single unit. The main purpose of extensions basically is to make it easier to maintain. So by wrapping other objects into a single unit, it's easier to maintain them. The types of objects you can wrap up into a single unit as an extension includes cast, indexes, functions, and other objects. I have logged into my PG admin 4. I'm going to take a look at the built-in extensions that has come pre-installed with the instance of Postgres database, and also the sample database we loaded has also got an instance of an extension. So I'm just going to expand the databases. We've got two databases listed, so I'll click on the plus sign. We'll take a look at the sample database we loaded, which is this DVD rental. So I just expand that, and you can see we've got one extension, and the extension is a PLPG-SQL. So if I go to the properties, we can see the name, that's the ID, the owner. Let's look at the SQL. This is the SQL basically used to create it. This is the schema it belongs to, PG_catalog. Let's look at the stats. Dependencies, non-dependent. Okay, it's got some dependence here. There is a function that's dependent on that, and we've got these functions all dependent on that. So there is some dependence, but no dependencies. So extensions basically are used to wrap other objects to make it easier to maintain. So we'll go on extension here in PLPG-SQL. So let's have a look at the default database that was installed, which is this Postgres. If I expand that, it has two extensions. So let's have a look at what the extensions are. We've got the PLG-SQL, which we've looked at an instance in the sample database, and we've got one called admin pack. So I'm going to right click and go properties, so we can look at the properties. That's the name, and it tells you what it does. It's for administrative functions for Postgres. So a lot has been wrapped into this admin pack. We can look at the definition. Just tells you the version. Look at the SQL, nothing has changed. If we come here, right click, if you want to create a new extension, you use that with the create command and click on create extension, and that will give you all the options and parameters to add. Again, you can delete or drop a extension. You can cascade, you can create a script from it. So if we wanted to create a script from it, it should also generate a script. So this is a script. I'm just going to bring it down a bit. So you can see this is basically a script that's been used to create this extension called admin pack. So that's it for this lecture on extension. Extensions basically is a concept where you wrap other objects into a single unit, making them much easier to manage. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'll be going through some basic database concepts. We'll begin with the database, what a database is. A database basically is a collection of organized information or data that is stored in a table. A table, on the other hand, stores information in rows and columns. So a table will store usually a collection of related data entries in columns and rows. This table here is similar to what a database table is. So the columns are horizontal. For example, this word terminology can be referred to as a column, and this word meaning can be referred to as a column. The rows, these rows are going vertical. So these database, table, columns, all these are referred to as row. So basically this is how the table is structured in a database table. So you've got the columns going horizontal, and the rows going vertically. Each row in a database table is referred to as a record. A schema is a collection of database objects. I will show you examples of this later on in the course. So any item is referred to as an object in a database. A database is an object, a table is an object, a view is an object. So these are all objects. So a collection of database objects housed in a container is referred to as a schema. Primary key. A primary key is a unique identifier such as your driving license number or your health insurance record. Is a unique identifier that is used to identify unique records. So no two people can have the same records. So you are able to enforce that using a primary key. A foreign key, on the other hand, is like a primary key, but not exactly. It is used to reference a primary key in another table. For example, if table A has a primary key and table B has a primary key too, so you can have the primary key from table 2 acting as a foreign key in table 1. Likewise, you can have the primary key in table 2 acting as a foreign key in table 1, or vice versa. So a foreign key usually is used to reference another primary key in another table, but primary keys are unique per table. You can't have two primary keys in one table. There are two other concepts I want to illustrate with you. We've got the relational database. A relational database is a database with related tables. Also, we've got the concept of relational database management system. It's referred to as RDBMS for short. It is the software that manages the databases. So examples of the relational database management systems are Oracle, Microsoft SQL Server, MySQL. There is a lot more, but I've just restricted my examples to these three. So these are the basic database concepts that you will come across when working with SQL. Hello and welcome to this lecture. In this lecture, you will learn about the data types in Postgres. We're only going to cover the basic data type. And the data types includes the Boolean, which is a Boolean value, character, number, temporal, array, and special types. A Boolean data type can hold one of three possible values. So it can either be true, false, or null. Null meaning there is no value. So when you insert data into a Boolean column, Postgres will convert it into a Boolean value, which could be yes for true, or false, or N for no. So if the value is a 1, it will be a yes or a true. If the value is a 0, it will be a no or a false value. A null value means you don't know what the value is. So null doesn't mean, it just means empty. You don't know it. There are three main types of character data type. So you've got the char, you've got the varchar, and you've got the text. So the char data type basically is a fixed length character with blank padded. So what that means, if you insert a string is a text. If you insert a string that is shorter than the length of the column, Postgres will pad the spaces to make up for the other. The n here refers to the character. So you can have, maybe if you've got 4 characters there, what you're saying is that you want the column to take 4 characters. If you only enter 2 characters out of the 4, Postgres will pad the other spaces to make up the 4 characters. That's what that means. However, if the character is longer than the length you have specified, for example, if I specified 4 characters and I insert or try to insert 5, Postgres will complain because the character limit has been exceeded. The next is the voucher. The voucher, the n here represents the number of characters that you pass in there for it to accept. Voucher basically is a variable length character string, so you can accept strings or text or variable length. You can store up to n number of characters with variable length characters, so you can store any amount with this variable length character. The n value, it's variable. So you can store up to n characters with the variable length character strings. Postgres does not pad any spaces when the stored string is shorter than the length of the column. Unlike the char, if for example I specify 255 characters and you only enter say 10 characters, Postgres does not bother to pad the other spaces as it does with the char type. The next is the text. So the text also is a variable length character and it accepts strings. If you notice, I have not put an n value here because with the text type, you don't need to specify the length, of the character. So basically, theoretically, a text has an unlimited length of characters. So you can enter an unlimited number of text you want in that field if you wish to. The number data type. Postgres provides 2 distinct type of numbers. The first is integers, and there are 3 types of integers. So you have the small integer, which basically is a 2-byte signed integer. And then you've got the integer itself. This is a 4-byte integer. And then you've got the serial. The serial basically is the same as integer, except that in Postgres, it generates and populates values into a column automatically for you. So if you're creating a table, for example, and you have an ID column and you want it to auto-populate, you'll have to use the serial data type. The next type of number data type is the floating point number. There are 3 main types of floating point numbers. You've got the float, and the floating point number whose precision at least n represent the number and has up to 8 bytes. The next is the real or float 8. This is a double precision or 8-byte point number. The float can also have up to a maximum of 8 bytes, but it must have at least an n value. Then we have the numeric or numeric PS. This is a real number with P digits and S number, these are precision numbers. So we have the P digits with S numbers after the decimal points. The next type of data type is the temporal data type. This data type stores things like date and time related data. There are 5 main temporal data types in Postgres. So I'll start with the first one, which is a date. The date basically stores date values. And then we have the time that stores time of the day value. We've got the timestamp that stores the date and the time. And then we've got the interval. The interval stores periods of time. And we've got the timestamp. This stores both timestamps and the time zone data. The timestamp is a Postgres extension to the temporal data type. The next data type is the special data type. So besides the primitive data types, Postgres also provides several data types related to the geometric and network. So the first is the box. Basically, this is a rectangular box type of data. And then you've got the line. So some of these are used with geometric or network related. And then you've got the line, which is a set of points. And then you've got point, which is a geometric pair of numbers. And then you've got the one seg, which is a line segment. Then you've got polygon, which is a closed geometric. You've got the inet, which is an IP4 address. This is a network related. And then you've got the MAC address, basically refers to the MAC address on a network card. The final data type I'm going to talk about is the arrays data type. An array basically allows you to store an array of strings. You could also store an array of integers and so on. Array basically are multiple variables. So a variable can store one value. An array can store multiple variables as one value. So you can store an array as strings. You can store an array of integers and so on. Just remember that an array contains several variables. Where a variable stores one value, an array can store multiple values as one array. So that is it for this lecture on data types. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to use the Postgres unique constraint to ensure that the value in a column or a group of columns is unique to a table. So there are times where you want to ensure that certain columns have unique data across the table. For example, you may want the email addresses to be unique, the username to be unique, or the employee ID to be unique. For example, if you are dealing with social security numbers, you don't want two people to have the same social security numbers and so on. So you ensure that by using unique constraint. Say for example, we're trying to create a table. Normally when you create or you implement unique constraint, it is better to do that at the table creation stage. So when you're creating a table, for example, I'm creating a table called person. These are the columns. And you can see here on the email, I've implemented a unique, I've added unique, which means I want every record in this column to be unique. So you can apply unique constraint to multiple columns within a table. So let me show you how this works by actually creating this table. I've already added a script to my query tool, and I'm going to create a table inside the fruit database, this database here. So this is the script to create a table, and I've added a unique constraint to the email column. So let me go ahead and run the script to create a table. Okay, there's some error. Okay, now I've created a table. What it was, I had other scripts inside this editor, and he was getting confused with which one I was trying to run. So now it has created the table. So now it's time to insert records into the table. So this is the script I've written to insert a record into the table. So I'm just going to highlight it here. So I'm going to insert this record into the table we've just created. These are the columns of the table. This is the name, and that's the email address. The email address is where I've applied the unique constraint. So let me run that. If I run that, it tells me query successful. So I now have a data with someone called with these details on the table. So let me quickly do a select statement on the table. I'll do select star from person. All right, so let me just refresh the table list. Okay, so I've got a table called person. So I'm just going to highlight. When you have several scripts in the editor, it's probably best to highlight the script you're trying to use. Sometimes the editor can get confused, even though you've got a semicolon to indicate that the statement ends there. So I'm just going to run this so you can see. So this is our table. It contains one record. It's got John, Doe, and so on. All right, so that's the record for that table. Quick thing I want you to notice, although it's not part of this constraint, is that if you notice here, the primary key for this table, I've given it, it's got data type of serial. So when I was creating the table, when I was doing the insert, I didn't have to automatically add the one number. When you're using the serial data type, it automatically populates this primary key or this integer value. All right, so it's done that for me. Anyway, that's not what this is about. So this is about unique constraint. All right, so I've added one record. So let's assume I want to add a second record. I've now got someone called John. I want to add Jack. Okay, I want to add Jack to the table. Notice I'm going to use the same email address as I've used for Doe, because they've both got the same initials, haven't they? This guy is John Doe, this guy is Jack Doe. So they've both got same initials, but there's going to be an error because I've implemented a unique constraint. So let me run that. You can see the error. Duplicate key value violates the unique constraint person email key. All right, so it tells you here the email j.doe@bluelime.com already exists. Okay, so that is the constraint working. So it will not allow duplicate entries in a column or duplicate data. So to get around this, I can just change this to 2 and make this j2 dot. Let me insert that, and hopefully that should work. You can see it has not worked. If I do a select on the database, on the table, I should have 2 records in there. I've got a John Doe and a Jack Doe. You can see the email addresses are different because they are now unique. So that's how you implement a unique constraint. Thank you for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the where clause. The where clause basically is used to act as a filter to filter rows that are returned from a select statement. Without the where clause in a statement, it can return all the data you have specified. So the where clause acts as a filter to filter out the records that are returned from a select query statement based on certain conditions or criteria you have specified inside the where clause. So let's look at how you write a where clause. So the syntax basically is this. You, after your select statement, after you key in this keyword, you've done your column select if you're selecting specific column. If not, if you're selecting all the column, then you can replace the column names with asterisks. You specify the name of the table and then the where clause. The where clause usually appears after the from. Okay, so you must place it after the table name, which is after the from keyword. Then you place the where clause. Inside the where clause, you specify the conditions that must be met for the returned data from the query. All right, say for example, you can specify that you want to return data from column 1, column 2 from this table where maybe the first name begins with this, or certain conditions matches a certain criteria. So the where clause will be acting as a condition. If the condition you specified in the where clause is met, then the relevant data is returned. So let's illustrate how this where clause is used. So I've logged into my pgadmin 4, and these are the tables from this DVD rental database, the sample database here. And I'm just going to pick a table to work on. I've got a table here called customer. So let me quickly right click on this table and go to the properties so we can see the properties of the table. So this should reveal things like the columns of the table. So if I click here now, we can see these are all the columns of the table. So let me run a quick query on the table. I'm just going to right click and go query tool. I'll wait for the query tool to launch, and then I'll write a very quick select statement. So I'm going to do select star from customer, which is this table here. And that should, if I execute this, that will give me, it will return all the data. You can see 599 rows retrieved. All right. So say for example, I don't want all this data retrieved. It has received 599 rows. And if I don't want all 599 rows returned, I can apply a filter. Okay. And the filter will reduce the amount of records returned. At the moment, it has returned 599 rows. You can see here saying 599. So I want to apply a filter here. So to do that, I'm going to get rid of this semicolon there and type in the where clause. So this is a where clause that will act as a filter. Then I need to specify the condition for the where clause. So I'm going to say where the store underscore ID. Notice here we've got store ID 1, some of them are store ID 2. So I'm going to say where the store ID is equals to 2. I've now applied a filter. So the data that's going to be returned from this query should be less than 599 records, because I'm using this filter here to restrict it. So I only want to return data that matches the store ID number 2. Anyway, where the store ID is 2, those are the data I want returned. So notice I've used an equals to here. Equals to is known as a comparison operator. So that's what we use to compare. Okay, so if I run this now, just watch out, it should return less than 599. So let me execute that. Look out here, it says 273 rows retrieved. So we've been able to filter the rows that have been returned using this query here. So the where clause here acts as a filter, and you can specify any condition inside the where clause. So whatever condition you specify in the where clause, when the query is executed, it will compare that condition, and based on the condition you've specified, it will return the data that matches that criteria. So that's how you use a where clause to act as a filter. Thanks for watching, and bye for now. The where clause is also important when you are deleting records. So you can use the where clause to act as a filter so you don't delete all the records from a table. Inside the where clause, you can specify what you want to delete or what you want to update. Very important, the where clause. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from all the columns within a table. To query data from a table is quite easy if you want to query all the data. The syntax you use is this, very basic and simple. You just type in the select keyword followed by the asterisk symbol. The asterisk symbol basically means retrieve all the columns and all the rows from a table. You need to specify from keyword, which indicates where you're getting the data from. So let's go ahead and do that. Let's log into our PG admin tool. So go to all programs. If you're on the Windows, click on the Postgres folder and click on PG admin 4. If you're on a Mac, look for the PG admin 4 icon and click to launch. Once it launches, we need to connect to the database and then begin writing the query. Once it launches, click on the plus sign on the left here to expand the server. It tells you you've only got the one server. Click on the plus sign here and you should get a prompt to sign in. So enter your password. This will be the password set during the Postgres installation. Ooh, looks like I've got mine wrong. Let me try again. Okay, this time it tells you server connected on the bottom there. So let me expand the databases. The database we are going to use for this lecture is the sample DVD rental database, this one here. So I'm going to click on the plus sign. If I click on the plus sign, it should tell me here database connected on the bottom right. So I'm connected to the database. You can see the dashboard here. I need to expand the schema. We've only got the one schema, which is public. So I'll click on the plus sign and that should reveal all the objects within that database. So the tables, this is what I'm interested in. Let's expand the tables. So these are all the tables for this sample database here, and I'm going to go for the customers table this time. So I want to query all the data from this table. Before I do that, I just want to check the properties of the table. I'm just going to right click on the table and go properties, and it's trying to retrieve data from the server. Let's give it a few minutes to do that. Okay, so it tells us here, name of the table is customer, the owner of the table is Postgres, schema is public, the table space where it stores this data is PG_default. So let's check the columns here. We can see these are all the columns of the table, and I want to retrieve data from all this column. I'm not going to be specific of which column I want the data from. I want the data from all the columns. So I want all the columns and all the records. So I'm just going to click exit. Next thing I want to do is access the query tool. So I'm going to right click on this table here called customer and click on query tool, and that will launch the tool I can use to write the query. So give it a few minutes. We now have our query tool here. I'm just going to drag that. The output will be displayed in this area here. So to build the query, you type in select. SQL is case insensitive, so you can write select in lowercase if you wish. It doesn't really matter. So I do select followed by the asterisk. Asterisk indicates that I want everything, all the columns, all the records from the columns and rows. And then I specify the name of the table. I like to write the keywords in capitals so that they stand out. And if you notice also, the keywords are also colored, makes them stand out. So from is where I'll specify the name of the table, which is customer, and then a semicolon. Semicolon is important, always good in case you have several statements inside the editor window. The semicolon indicates the end of one statement. So it's a good practice to always end your statements with a semicolon. So what this query is saying basically is get all the records from the customers table. This asterisk means retrieve all records from all columns. So let's execute that by clicking on this lightning bolt here. And it's trying to do that. And it tells you here 599 rows retrieved. So this is everything from this table called customers. All right. So you can see all the columns on top, and these are all the records, okay, from this table. It's 669, it says. Okay, so we've got everything, all the data that's ever been saved into this table. We have captured it using this simple statement. So basically, this is how you use the select statement to retrieve data from a column. If you use it with the select and the star, it gets every data from the table and displays it in the output. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to query data from specific columns within a database table. The syntax we are going to use is this. Basically, we use the select keyword followed by the column names, and then we select the name of the table and enter it into the from field. So this here is the structure or how we would write a select statement to query data from specific columns within a table. We are going to be querying data from our sample database, which is the DVD rental sample database. So let's go ahead and open up our admin tool and begin. So let's launch our admin tool. Go to your start, all programs. If you're on a Windows, if you're on a Mac, look for the Postgres folder and make sure you click to open the pgadmin 4 and give that a few minutes to launch, and then we can try and connect to the Postgres server and access the database. So give it a few minutes, it should load. Once it loads, you need to expand the server option within the browser here. Click the plus, and once you expand, you need to click on this and you should have a prompt that you have to enter your password. So click on the plus sign, it will give you this prompt here. So enter the password. The password will be the password you would have set during the Postgres installation. So just enter that password in there. Once you've entered it, click OK, and you should now, it tells you server connected just on the bottom. So once you're connected to the server, you have access to all the databases and the objects. So I'm going to expand this databases option here. It says we have 2 databases, so we'll give it time to expand. The database we're going to interrogate or query is this sample database here called DVD rental. So click on the plus sign to expand the database objects. All right, so it tells you here database connected. So we need to expand the schema area and expand the public schema and get access to one thing that is good practice is before you query data from a table, it's always good to check the table structure. So these are the tables for the DVD rental here, and the table we are going to query for this lecture is going to be, let's just pick a table. I'm going to query this table here called city. So I want to check the structure first so that I see how many columns it's got and so on. So I'm going to right click on the city here table and go properties. So when the property page opens up, it gives me the name of the table. It's called city. Tells me who owns the table. It's owned by this user here. The schema is public. Table space is this. So let's check the columns. This table has 4 columns. This is the data. These are the data types. So we've got city ID, city, country ID, and last update. So what I'd be interested in from this table is the city column and the country ID. So I want the city and the country ID. So those are the 2 columns I want to query data from this table. So let me begin by writing the query for that. So I'm going to right click on this city here and click on the query tool, and that will give me the editor where I can write my query. So this is where I'm going to write my query. So I've already decided that there are 2 columns I need. I need the city. Let me expand these columns here so we can see them. So I need the city column and the country ID. So this is how I would specify the select query. To select, SQL is case insensitive, so you can make it uppercase or lowercase, it will still work. So I'll do select the columns. So the first column will be city, comma, followed by country ID. Country underscore ID. And then the next will be the from. From will be the name of the table is called city. And this is basically the select statement completed. So I'm querying data from specific columns here. The columns from this city table here is the city, which is this column here, and the country ID, which is this one. Rather than get all the data, I only want specific columns. And I've ended the statement with a semicolon. Notice the keywords here are highlighted, so you know that they are keywords, the select and the from. Now I'm going to execute the query and the output should show here. So click on this, that looks like a lightning bolt, or you can press F5 and it should execute the query. And so this is how it tells you total query runtime 600 rows retrieve. So this is basically the city and this is the country ID. All right, it tells you here, it shows the data type it shows you the data type and then the name of the columns. So that's the city here. This for example, this is a city called Abu Dhabi, and the country ID is got 101. And if I scroll down, we can just pick another country. We've got Dallas here. We've got 103 city. These are all cities. And then these are the country IDs. So basically, this is how you retrieve specific data from a table by selecting specific columns, and then you query the data from those columns. So that's it for this lecture. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to remove duplicate records using the distinct keyword. There may be times where a select statement may return several or multiple duplicate records, and you may want to reduce the duplicates. And the way you achieve that is by including the distinct keyword in your select statement. Let's have a look at the syntax to create a distinct statement. So this is what you do basically. You include the keyword distinct inside your select statement, followed by the column names you want to apply the distinct to. And obviously you still have to use a from to indicate the tables coming from. You can order the data after the distinct has been applied, and you can order by either in ascending order or descending order. So let's have a look at how this works. So log into your pgadmin4. I've already logged in, and once you've logged in, select the DVD rental database. Just click on the plus sign to expand the database objects, and it should tell you the database is connected. Expand the schema and click on the public schema. Let's expand the tables. So these are all the tables for that sample database, 15 of them in total. Before we go ahead and remove the duplicates, I want to run a quick query that will show the duplicate entries. So the table I'm going to go for here is this table called inventory. So if I click on the plus sign, you can see all the columns from that table. There's only 1, 2, 3, 4. The column I am interested in is this column here called film ID. So right click on the name of the table and go query tool. It will launch the query editor. So I'm going to write just a very simple select statement, and I'm going to select just one column here, which is this film ID column. So I'm going to select film ID, film underscore ID. From the table name is called inventory, and a semicolon to end the statement. So now let me execute by clicking on this icon here that looks like a lightning bolt. If I click on that, it will output the query. So you can see all these duplicates here. These are all duplicate entries. You can see 1, 1, 1, 2. So there's a lot of duplicate entries. You see several 4s and so on. So this is what I want to get rid of. And the way I do that is to add a distinct keyword to the select statement. So I just come here and type in distinct. Oh, I got it wrong. Remove the I, remove the, that's it. You can see the color has changed as well because it's a keyword. If I now execute this query, these duplicates will be gone. It will only show me one instance of each. All right, so I'll execute that again, and you should see that the duplicates are gone. What I want to do also is add, I want to order it. So I include an order by. I'm going to order by the film ID. And I'm going to order it in ascending order. That is from A to Z. If I run this again, it will filter the data. You can see now the data has been returned and it's filtered, and there's no duplicates. You can see I've got 1, 2, 3, 4 and so on, but the duplicate entries have been removed. So that's basically how you use the distinct keyword to get rid of duplicate records in a table. So that's it for this lecture. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, we are going to learn how to sort data returned by a select statement. So we are going to use the order by clause inside our select statement to activate the sorting of the data returned. This is what the syntax will look like. So the format basically will start with a select keyword. We will select specific columns from a table and then apply the order by clause in order to sort the data returned from the select query. So let's launch our pgadmin4 tool by going to all programs. If you're on the Windows, click on the Postgres folder and then pgadmin4. If you're on a Mac, also locate the pgadmin4 icon and click to launch the icon. Once the tool launches, let's connect to the server by clicking on the server plus here, and then if you click on the Postgres server, it should give you an option to log in. So click on the plus sign and we just need to enter the password. So the password will be the password set during the installation of Postgres. So I'm connected. It tells you here server connected on the bottom right. So let's access the database. We have two databases here. The database we are going to run this query on is the DVD rental database. So I'm going to expand that. It tells you here database connected. So let me expand the schema and then the public schema. And let's look for the table. And these are the tables for that database. We got 15 tables, and the table I'm going to query here is the country table. I'll go for the customer. Sorry. I'm going to query the customers table. So if I expand that, you can see all the columns from this customer table. Let me just expand this a bit so you can see. So these are all the columns from the customer table. I'm going to select specific columns here. I'm going to select the first name and the last name column only. So let me open the query window by right clicking on the table name and clicking on query tool. That will launch the query editor from where we can build the query. So this is a query editor. The query will be outputted in this area here. I'm just going to drag that down a bit to create some more room. All right, so let's write the query here. The query I'm going to write will be a select. I'll start with the first name column. Always specify the column the way it's been defined. So I'm going to do first name underscore name. You use a comma to separate the column names, and then I've got the last name here, and I'll type in last underscore name, and then I'll specify the from. Always good to write your keywords in capitals to make them stand out. The editor here also gives them a specific color to make them stand out. So in the from field is where you specify the name of the table, which is customer. And that is basically it. I'm not going to include an order by yet. The reason being, I want to execute this query so you can see the difference when the data is sorted and when the data is not sorted. So I'm going to click on this icon here to execute. As you can see, this is the output from the query here. The data is not sorted in any way. You can see here the first name here. You got say Jared, you see Linda, you got Elizabeth, you've got Dorothy. So there's the data is not kind of like, it's not ordered in a way. So it is returned the way the data was entered into the table. So we can change that by adding an order by clause. So the way it is now, without using an order by clause, it sorts it in ascending order. So now I want to be specific and apply an order by clause. So to do that, when you are adding an order by to your statement to filter data, it's usually the last thing you add to the statement. So I'm just going to add an order by. I do order by. I'm going to order by the last name column here. So you can order by first name or last name. It doesn't really matter, but I'm going to order by last name. So I do, I'll do last name. Underscore name. And then I want it in a descending order. When you use the order by, you have to specify how you're ordering the data that is returned by the select statement, either in a descending order or ascending. This is the current structure here of the output. You can see Ellie, Smith, there's no order here. You can see the A appears here, Anderson, and you can see J there. So by the time we run this query again, after adding the order by, this last name will be structured in the way it is sorted. You'll see a more structured ordering of this column here. So keep an eye on this column here. All right, so let's execute the query again. And we just see, as you can see, we've ordered the data in a descending order. That is from Z to A, if you will. You can see here, it displays young first, Y, and then if I scroll down, you can see, you probably see if there's any A, it will be right at the bottom. Let's scroll down. You can see these are the A's because of the way I have ordered the data. All right, so if you're ordering in descending order, it will take the format of Z to A. If you're ordering in ascending order, it will be from A to Z. So if I change this, for example, from descending to ascending and run this again, it should change the structure. You can see now the ordering is different. Is from ascending means A to Z. You can see that now A appears first and so on. So that's how you sort data returned by a select statement. So if you don't specify the order by, the default is ascending. So when you are ascending, it takes it from, it sorts the data from A to Z. If you're using descending, it sorts the return data from Z to A. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I will be introducing you to the Postgres order by clause. When you query data from a table, Postgres normally returns the rows in the order that the data were inserted into the table. In order to sort the result set, you use the order by clause inside the select statement. So basically, the order by clause allows you to sort the rows returned from a select statement, and it does this in ascending or a descending order based on the criteria you have specified. So the main purpose of the order by clause is to sort the data that has been returned from a select statement, and you can specify the way in which the order is returned or it is sorted By default, it is sorted in ascending order, but you can change that by specifying your preference inside a select statement. So let's look at the syntax. So the syntax is this. This is how you would include an order by clause inside your select statement in order to sort the data that is returned from the query in a particular order. So you start with the select statement. So you're selecting, say, column 1, column 2 from the table. This is the table you're selecting it from. And then you specify the order by. The order by is usually comes after is the last thing you add in a statement. So you usually specify the order by clause after the select statement, the from, and then you specify the order by. And when you order by, you can specify the column you want to order by. So you can order by a specific column. Here in this syntax here, we're saying we're ordering the first column in ascending order, and we're ordering the second column in descending order. So that's how you specify the syntax when you want to sort data returned from a select statement. If when you write a select statement and you don't specify an order by default, the data that is returned from a select statement is sorted in ascending order. So if you don't specify an order by, it would automatically sort the data in ascending order. In other words, it will order the data in the order in which the data was inserted into the table. For example, if Joe Bloggs was inserted into the table before Anna Smith, then when the query is returned, it will return Joe Bloggs before Anna Smith, unless you specify an order by to sort the data. So when you are ordering data or sorting data, you can sort it by multiple columns. If you're sorting by multiple columns, you need to separate each of the column by a comma, just as you would here when you are selecting columns to retrieve data from. So if you are ordering by several columns, make sure you separate each of the column by a comma. So the key purpose of using the order by clause is to help you sort or filter the rows returned from a select statement. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to divide rows into groups by using the group by clause. The group by clause is used to divide the rows returned from a select statement into groups. Using the group by clause, you can apply aggregate functions to the columns. For example, you can apply aggregate functions like the sum to calculate the sum of the items, or you can add the count aggregate function to the columns. With the count, it enables you to get the number of items in a group. So let's look at the syntax for implementing a group by clause. So it's always implemented with a select statement. So you got the select, then you followed by the column name, then the aggregate function, and inside the parentheses for the aggregate function, you specify the column you are applying the aggregate function to. Then you select the table name from the from field, and then you apply a group by column. You then group the column by the column name after the aggregate function has been applied. What are aggregate functions? Aggregate functions are basically used to perform calculations on data. Aggregate function most returns a single value based on calculations from the columns. So the data returned by an aggregate function is a single value, but calculated from the values in a column. Let's have a quick look at a brief table showing some aggregate functions. So this is a brief table here of some common aggregate functions and their description. So we've got the AVG or average. It's used to return average value. The count returns the number of rows. The max returns the largest value. The mean returns the smallest value. The sum returns the sum. The first and the last returns the first and the last values. So let me show you an illustration of how a group by clause works. So I'm going to use this DVD rental database, and this database has got 15 tables, and I'm going to use one of them to illustrate. The table I'm interested in here is the payment table. So let's take a look at the columns. These are the columns in the table. So you've got the payment ID, customer ID, staff ID, rental ID, amount, and payment date. You don't always have to use an aggregate function with a group by. You can use the group by clause without applying an aggregate function. So I'm going to show you an example where you don't have to use an aggregate function. So let me open up the query tool, and I'm going to pick a few columns from this table here. So I'll start with a select statement. Type in the select keyword, followed by, I'm going to pick the customer ID. Comma, and then I'm going to, I'm just only going to pick one column from now, and then type in the from field. The from will be payment. Then I'm going to apply a group by. I'm going to group it by the customer ID. Underscore ID. So what this query will do, it will get data from the payment table and group the result by the customer ID. So let's run the query so we can see. Ooh, I've got an error there. The reason being, you can see these dotted lines. It means that it doesn't recognize that column. I've got it wrong. It should be customer underscore ID. So let me rectify that. All right, and then semicolon. Now it should work. Ooh, still doesn't work. Okay, the query has finally worked. For some reason I got the underscore wrong. Anyway, so this is it. This query here, as I've used it to get the data from the payment table and grouped the result by the customer ID. So this is the kind of thing that an aggregate function will do as well, because when an aggregate function is applied, it will return a single value, as you've seen here, but you don't always have to use the aggregate function with the group by clause, as I've illustrated in this example. I'm going to amend this query and add an aggregate function. The group by clause is always useful when it is used in conjunction with an aggregate function. For example, to get how much a customer has been paid, you can use the group by clause to divide the payment table into groups. For each group, you can calculate the total amount of money by using the sum aggregate function. So let's do that. I'm just going to amend this query. So I'll leave the column as a customer ID, and after the column I'm going to apply an aggregate function called sum, and I'm going to do the sum on the amount. This table has an amount column, which is this here. This amount column is what I'm applying the aggregate function to. So let me execute this query. Ooh, made some error there. Amount. Okay, it thinks I've got the amount wrong. Yeah, what I should have done is put a comma after the first column here to indicate that I'm adding another column. So let's try again. Okay, that's much better. As you can see, the group by clause sorts the result set by customer ID and also adds up the amount that belongs to the same customer. So whenever the customer ID changes, it adds up the row to the returned result set. You can also use an order by with a group by clause. So what I can do, I can add an order by just at the bottom here. I'll get rid of that semicolon, come here and type in order by, and I'm going to order by the aggregate function and then the amount, and I'm going to do that in descending order. Okay, so watch out for this result output. It should change. I'm going to click on that. As you can see, the format has changed. So by adding the order by clause with the group by clause, it sorts the groups as well. You can also use the group by with a count function. So I'm going to modify this query slightly to use the count function. This payment table here has a staff ID. So what I'm going to do, I'm going to change this customer ID to staff ID. And I'm going to apply a count function. And the column I'm going to apply the aggregate function to is the payment ID. So I'm going to change that and add a payment ID. And I'm going to group the result by the staff ID. And I'll get rid of the order by and put a semicolon to end the statement. So to count the number of transactions each staff has been processing, you group the payments table based on the staff ID, and then you use the count function to get the number of transactions as this query indicates. All right, so let me run that and then we can see the output. So that's it. The group by clause sorts the result set by the staff ID. So it keeps a running total of the rows, and whenever the staff ID changes, it adds the rows to the returned result set. So that's it for this lecture on using the group by clause. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the having clause to eliminate groups of rows that do not satisfy a specified condition. The group by clause is usually used in conjunction with the group by clause. It is used to filter group rows that do not satisfy a specified condition. Let's have a look at the syntax to see how you would implement an having clause. So basically this is how you would implement it, usually after the group by. So you start with the select keyword followed by the column name and then the aggregate function you want to use, and inside the parentheses the aggregate function the column you want to apply the aggregate function to. And then you specify the table name in the from field, and then you apply the group by what column you're grouping it by, and then you apply the having condition. The having condition always comes after the group by. The having clause sets the condition for the group rows created by the group by clause. Although you can use the having clause with the group by clause in conjunction, in Postgres you can use the having clause without the group by clause. So let me show you an illustration of how the having clause is used. Before I do that, I've got a query here I just want to run. Basically this query is just showing the group by clause. So I've got the select keyword. I'm using the customer ID from this payment table here, and I've got the sum aggregate function that I'm applying to this column called amount from the payment table, and I'm grouping it by the customer ID. So let me run that so you can see what it looks like before I add an having clause. So this is what the query looks like at the moment. I'm going to add the having clause in order to implement or set some conditions. So after the ID here, I'm going to take off the semicolon and then implement the having clause. Inside the having clause is where I'm going to specify some conditions. So I'm saying having sum, and I'm going to use the amount column, so this is the condition I've set. So after the group by has been applied using the customer ID, I've set extra condition using the having clause with the sum aggregate function. So it's going to apply to any amount greater than 200. So we should have a much reduced output. So let me run that and you can see the result. You can see we've only, so this, by using the having clause, only conditions that match this criteria have been displayed. You can see this amount here, these two amounts match this, they're greater than 200. So this is an example of how you can use the having clause. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture you will learn how to truncate and drop a table. Truncate basically means you remove all the data from the table. You strip the table of its data. And drop basically means delete. When you drop a table, you are deleting it or removing it from the database. So truncate removes all the data from a table, while a drop will delete the table from the database. So the syntax you will write to truncate a table will be this. You start with the word truncate, followed by the word table, and then the name of the table. If you were to drop a table, you start with the word drop, followed by the word table, and then the table name. Let's see how this works. I've logged into my PG4 admin tool, and I am going to delete, and I'm going to drop and truncate a table from the fruits database, this database here called fruits. And the table I am going to truncate and drop is this table here called person. So I'm going to right click and go to query tool, and that would take me directly to the table. And what I'll start with the word truncate. I'll type in TRUN, truncate, followed by the word table, followed by the name of the table. Name of the table is called person. All right, so before I do that, I want to do a quick select statement so that we can see what data is in there. All right, so I'm just going to highlight this and execute. So we've got two records or two rows of data in this table here. All right, so I'm going to truncate. When I truncate, it should get rid of the data. So I'm highlighting and I execute. It says it's done that. So let me run the select statement again. And the table should be stripped of data. So it has successfully stripped that table of its data. So that's basically what a truncate does. All right, now let's try and drop this table. We want to remove the table from the database. So to remove the table, I'm just going to replace the word truncate with drop. Now, if I execute this, it should delete the table. All right, so if I try and run this query again, if I refresh the table list here, it should change from 3 to 2. It has changed to 2. If I try and run this query again, it will tell me that table does not exist. Error, person does not exist. So that's how you truncate and drop a table. Thanks for watching. Bye for now. Hello and welcome to this section. I'll be introducing you to the PostgreSQL stored procedures. What are stored procedures? Stored procedures are basically a set of SQL statements that can be given a name and stored on the relational database management system as a group, and can be reused whenever it is required. They can also be shared by multiple applications or programs. PostgreSQL basically uses stored procedures for developing functions. So they allow you to extend the functionality of the database with user-defined functions. So user-defined functions are also represented as stored procedures. You can use stored procedures to define various types of functions. For example, you can use it to create triggers or custom aggregate functions. Let's take a look at the advantages of using stored procedures in Postgres. The first is basically reduced network traffic. So basically, a stored procedure reduces the number of round trips between application and database servers. So basically, all the SQL statements are wrapped inside functions stored in the PostgreSQL database server. So the application only has to issue a function call to get the result back, instead of sending multiple SQL statements and waiting for the result between each call. It wraps everything and makes the round trips between the application and the database server. It reduces that and therefore reduces the network traffic. It also increases the application performance. because user-defined functions basically are pre-compiled and already stored in the database server, so it makes it a lot easier for the application to reference it. Also, stored procedures are reusable, so you can reuse it in many applications or programs. Once you've developed a function, you can reuse it in any application. Once it's created, that's it. You can reuse it anytime. So let's also take a look at some disadvantages. So some disadvantages of using stored procedures include slow software development. So it is slow in software development. This is because it requires specialized skills that many developers do not possess. So there's probably not enough developers with skills to support that in software development. So as a result, that can impact on the software development time. It also makes it difficult to manage versions and also hard to debug. Makes it hard to debug and manage the versions. Another disadvantage is that it may not be portable to other database management systems like MySQL or Microsoft SQL Server and so on. So these are some of the key disadvantages of using stored procedures in PostgreSQL. So in this lecture, I introduced you to PostgreSQL stored procedures, which in a way are basically a bunch or set of SQL statements that are stored in your database. They are also user-defined functions. So they are functions that are defined by the user, and you can use them to create triggers, custom aggregate functions, and other stuff. So the key thing to note is that they are basically user-defined functions that are stored in the database. Many thanks for watching, and bye for now. Hello and welcome to the introduction to this section, which is the Postgres CRUD operations. CRUD basically is an acronym for create, read, update, and delete. A lot of the times, the operations you will perform on a Postgres database will be to create, to read, to update, and to delete. You also obviously need to add records, and you do that with the insert command as well. But CRUD stands for create, read, update, and delete. So we'll be performing these operations in this section. Thanks for watching. Hello and welcome to this lecture. In this lecture, you'll learn how to create a database using the PG4 admin tool. To access the admin tool, you need to go to All Programs if you're on a Windows and locate the Postgres folder. If you expand that, the PGAdmin 4 tool is located inside that folder. So click to launch the tool. Give it a few minutes to launch. When the admin tool loads up, just click to expand the servers and click on the Postgres server. Once you click on that, it will give you an option to log in. So if you can just enter the password that you entered during the installation of the Postgres server. Click OK and it should give you access. It tells you server connected on the bottom right. So now to create a database, we just right click on this databases folder here and click on create and then database. It should give you a dialog box to enter some details. You need to enter the database name. I'm going to call mine fruits. And you can put a comment if you want. I'm just going to say database of fruits. And that's basically it. If you click save, it should create the database. Give it a few minutes. So the database has been created. That's the database here. When you create a database, it jumps to the top. So that's the database we've just created. So click on the plus sign to expand it so you can see more about the database. So these are all the objects that come with the database. This is a schema. If I expand that, it creates it under the public schema, and it also creates other stuff. So these are other objects that are created when you create a new database. So we can check on the properties by clicking on this property icon there to see what the properties are. And this is basically the properties of the database. So when you create a database, by default, there's certain things you enter, others can be completed for you. Like these here grayed out, there's the security option here. So none of that was completed. The definition was inserted for you. This is the encoding. By default, it gives you this table space. Collation indicates the language you're using. So I'm in the UK, so it's put that there. Template, it says no, I'm not using any template. Allow connections, yes. You can also decide not to allow a connection if you create a database and you just want to use it for testing purposes and you don't want any connection while you are doing some tests. Other things you can check, click on the SQL to see this is the SQL that was actually generated when you create a database. So if I was to create a database using SQL or SQL, this is how I would create it. From the information I provided, it has generated a SQL for the database. So this is the SQL used to create the database. Click on statistics. There shouldn't be that much. So these are various statistics relating to the database. Dependencies, there shouldn't be. Dependents, there's no dependents. So you can also access the property page by right-clicking on the database itself and going properties. Once you're in the properties, you can also click on the definition. This was the only information we completed during the creation of the database. The definition part was actually inserted for us by this tool. So all this here, we didn't do it. The tool inserted it for us automatically. And security, if at some point you want to implement security on the database, this is where you implement the security. So you have to be a guarantor to add privileges, and then this is where you grant the users. Parameters, if you've got any parameters, this is where you add it. Default privileges, if there's any, this is where it will be. And the SQL here tells you nothing has changed from the SQL that was used to generate, or the SQL that was generated when the database was created. So that's basically how you create a database using the pgadmin4 tool. Many thanks and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to create a table using pg4admin. Open up your pgadmin4 tool. I've already opened mine and I'm already logged into the server. So to create a table, there must be a database already in presence. So you create a table inside a database. So the database I'm going to create a table on is this database called fruits. We created this database earlier. So I'm just going to expand this database and look for the schema. This is a schema. Inside the schema, which is called public, there are tables. although there's no tables at the moment, but this is where you create tables from. So to create a table, you right click on tables, which is under this fruits database, and click on create and then table. And it should give you an option to enter the table name. So I'm going to call my table oranges. And it tells you the owner is Postgres, the schema is public. You can select a table space if you want. Once you've done, just click save and it should create the table name. So you can see here, that's the table oranges. We've now created a table. So we can go back to the table, right click and go properties, and we can add more bits to the table. We can add columns. So to add columns, we click on that. And before we do that, let me click on the general tab. You can see it's created it in the default PD underscore default table space. So let's go to columns and let's start adding the tables, the columns. It gives you option to, you can inherit from tables. If you've got other tables, you can inherit columns from tables, gives you that option. But I'm not going to do that. I'm going to create new columns. So click on this plus sign here to create a column. So with tables, they store data in columns and rows. So I'm going to call this category ID. And I'm going to select the data type, which it has to be an integer because it's going to be a number. So I'll select integer, leave this to blank, and I'll select, do I want it to accept null value? No, I want there to be a value. So I say yes. Do I want to make it a primary key? Yes, I want it to be the primary key. So this column here, all the records in this column will be unique. So that is the first column. So I click to save it and I can add more columns. I go back, go into properties, I wait for it to load, and then I go to columns again and I click on the plus sign, give me another row. So this time I'm going to add the name and I'm going to make the character varying character. So I'll type in character varying, so it'll be a varying character. You can give it a length. I'm going to give it 25 for the name. I don't expect there will be any fruit that will have more than 25 characters of name. Again, I want there to be a name. I don't want that value to be empty. So I say yes. I want it to be a null value. I don't want any null value. Null means there is no, you don't know. So, but by making this yes is forcing you to enter a name for the category. So I click save. I'm going to add one more. I go right click again. I go properties. Wait for it to load. And I'm going to go columns and click on the plus sign. I'm going to make this color. So I want to find out the color of the fruits. Again, I'll make this varying, character varying. I'll make it 25 as well. I'll leave this. So this can be empty if you're not sure what color the fruit is. So I don't want to enforce that. So I'll leave that option open. So if people are not sure what color it is, I want that left blank or null. I'll click save. So we've now created a table with 3 columns. If I expand this, you can see the columns of the table. So these are the columns. It tells you here 3 columns. There are other things you can apply to the table. If I go on the properties, for example, you can give it you can apply constraints. You notice because I've added a primary key to one of the table, it's made that a constraint. Constraint basically, in a way, is kind of like a check. It forces you. It means you can't progress unless you enter something in that field. Okay, so there are other options here: advanced parameters, security. You can add security to a table, so you can give access or restrict access. If you want to do that, this is the area you will be doing that. And the SQL basically tells you nothing has changed since the table was created. So if you want to see the SQL that was used to create the table, all you need to do, let me cancel out of this. I click save. So if you want to see the SQL or the SQL, you right click on the name of the table, and where it's got scripts, just click on create, and that will generate a script with the create command. So there you go. So this is a script that you would use if you were to create it without, that is not with the table, not from within the admin tool. So this basically is the SQL or the script used to, this script was generated when you created the table. So if I wasn't going to use the admin tool, I wanted to use SQL or SQL, this would be the SQL I would use to create the table. So that's it for this lecture on creating a table using the PG4 admin tool. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres create table statement to create a table in a database. Let's take a look at a typical syntax to create a table. So this is what a typical syntax looks like to create a table. You begin with the create table command, followed by the name of the table, and then in between the parentheses you specify the names of the columns the table will contain. A table can have as many columns as you wish to specify. So once you specify the name of the table, you then begin to define or specify the names of the column. So you start with a column name, followed by the data type, if it's going to be an integer, which is a number, or a text. And there are different types of textual data type, so you need to insert that. And then if you want a constraint on the column, you also need to add that. A constraint basically is a condition that you apply to a column. For example, you can add to a column that you don't want that column to be empty. There must be a value. That is a kind of constraint. So let's go over to our PG4 admin editor and create a table. I have already logged into the PG4 admin tool, so I'm just going to expand the list of databases. When you're creating a table, you need to create it in the correct database and schema. So I've got 3 databases listed here. The database I want to create a table on is this one here called fruits. So I'm going to expand that and then expand the schema, and you should see one for tables. There's only one table there. So what I need to do, I need to access the query editor. So I right click and go query tool. You can also access the query tool from the tools option and click on query tool. So I have now got my query tool open. So this is where I'm going to define my table. As you can see here in the editor, it says fruits on Postgres. So it knows that I am in the fruits database, which is this database here. So that's where I'm creating the table in. So I'll start with the create table command. Followed by the name I want to call the table. I'll call it berries, and then I have to enclose parentheses, and then I put my mouse in between the parentheses and expand it. So in between this parentheses is where I'll define the columns for the table. So the first column I'm going to define is going to be the ID. So I'm going to type in berry underscore ID. I'm going to make that the primary key. A primary key basically is a column or a group of columns that is used to identify a row that is unique in a table. If you are adding more columns, you put a comma at the end of the first column, and then you tab to the next line and then add another column. So I'm going to type in berry underscore name. Again, I need to specify the data type this time. It's going to be a voucher data type that will accept, that can allow 255 characters, and I'm going to set a constraint. A constraint basically means that you are applying some kind of restriction or a rule to that column. What not means that there must be a value in this column. That is, it cannot be empty. For illustration purposes, I'm just going to leave it with 2 columns. But you get the idea. You can add as many columns as you wish to in a table, but for this table I'm just going to make it really simple and just leave it at 2 columns. So I want it to be a 2-column table for now. Once you're done, you need to put a semicolon at the end to indicate that you are done with creating the table. You can always add columns later when the table has been created. Once you're done, you can now execute the query to create the table by clicking on this here. So once you've executed, it tells you that query returned successful. So successfully created the table. It tells you the command you used. Notice that I've added a data type. You must always have a data type when you're creating a column, so that the column knows what type of data to expect. So here, after the name of the column, you need to add the data type. This is an ID column, which is going to be an integer, which is a number. So this int means integer. So that's the data type for this column. So basically, this is a simple format that you can use to create a table. You can make it as simple as this one or as complex, whereby you can also add a constraint to several columns within a table, or you can also add constraint to the table itself. So let's quickly query this table that we've just created to see if we can communicate with it. So I'm going to quickly write a select statement. I'll do select star from berries. It's very important to always just check what you've done, just to make sure everything checks out. Okay, So I'm highlighting that and I click. As you can see, it's successful. It tells you we've got 2 columns in this table, tells you the data type, but there is no data inside the table. So we've got the table structure all in place, waiting for data input. Thank you for watching, and I hope the lecture has been useful. So this is how you create a table using Postgres create table command. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be introducing you to Postgres select statement. One of the most common tasks you will perform when working with Postgres is the task of querying data from tables, and you do that by using a select statement. So the select statement is basically used to query data from a table. The select statement can be very basic, or you can make it complex by combining it with several clauses. So you can use it in combination with other clauses to make the select statement more complex and powerful. There are several ways you can build a select statement, but let's have a look at the basic syntax you can use. A syntax basically refers to how something is written. So for a very basic syntax or a very basic select statement, you can specify the column. For example, a table stores data in columns and rows, just like in an Excel spreadsheet. If you wanted to query data from a table, you have an option. Rather than query all the data, you may want specific data to query. So you can do that by selecting the columns individually and specifying the table where the data is coming from. And the way you will write that statement is this. You do a select, which is a select keyword. Select indicates you are trying to retrieve data. Select doesn't cause any damage to the database. There's no risk because all you're trying to do is read data. So you start with the keyword select, followed by the columns you want to retrieve data from. Say you have a table that has maybe 20 columns and you only want to retrieve data for 2 columns. Rather than retrieve everything and then sift through what you want, you can specify the actual columns you want to retrieve data from. This also helps save network traffic. Rather than pulling all the data from a table, you only pull down the specific data you need. So you assume you want to retrieve data from column 1 and column 2 from a table that has 20 columns. So you just specify column 1 and then you separate each column by a comma. Okay, so I want to retrieve data from column 1, comma, and then column 2. You don't need to put a comma at the last column because there's only 2. If you were to add another column, then yes, you put a column after the 2, but not with the last column. And then you need the from. The from is very important because the query needs to know where it's pulling that data from. So the from is used to specify the name of the table. The other way you can write a select statement is if you wanted to retrieve all the data from a table. So you want all the columns and all the rows. You don't want to be specific. You just want to get everything out of that table. The way you specify that statement is this. You do a select keyword followed by the asterisk symbol. That asterisk symbols indicates that you want to retrieve all the data from all the columns and all the rows. You also have to specify a from field, which indicates the name of the table the data is coming from. So these are the two basic ways you can write a select statement. These are just basic. You can obviously make it more complex by adding other clauses to it. But at the very basic, this is what a select statement looks like. This is how you would write it. You can also obviously make the select statement more complex by adding things, other keywords or clauses to make the query more complex. But in a very basic select statement, this is how you would specify it. So that is it for this lecture. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn to use subquery to build complex SQL queries. A subquery basically is a query nested inside another query, and this can be with a select statement, an update statement, and also an insert statement. To construct a subquery, the second query is placed inside brackets, and also you have the where clause used as an expression in the subquery. So a subquery basically is an SQL statement that has another SQL statement embedded in the where or in the having clause. So let's look at a typical syntax. This is what the syntax will look like. So this portion here where you've got the brackets, that's this bracket here and this one here in between, this is known as the inner query. So this here is the embedded query. It is known as the inner query, while this portion here, this part of the query here, is known as the outer query. So I've changed the color to make it more pronounced. So the part in yellow here is known as the outer query, while the query in green, which has brackets around it, is known as the inner query. All right, let's start with a very simple example. So I've got a simple query here where I'm selecting the rental rate from this film. This is the film table, and this is the column I'm selecting, and I'm applying a AVG, which is an aggregate function, to this column here called rental rate, which is this column there. So suppose we want to find the films whose rental rate is higher than the average rental rate. So we can do this in two steps. First, we find the average rental rate by using the select statement and the average function, which I've specified here. The second step is to use the result from the first query in the second select statement to find the films that we want. So let's execute this so we can see the result. All right, so let me just expand that a bit. So this is the result from this query. So approximately is 2.98. So which means the average rental rate is 2.98. Now we can get the films whose rental rate is higher than the average rental rate. So I've implemented this query here. This query you can see to find the films whose rental rate is higher than the average rental rate. You can see here I've used the greater than sign. So I've said select the film ID, title, and rental rate from this film table where the rental rate is higher than 2.98. 2.98 was the average we found. So let me run this so we can see what it outputs. So this is the output from this query. You can see these are the rental rates. The way the code is implemented at the moment is not that elegant. So what we can do, we can make it elegant in 2 steps, and we'll do that by implementing a subquery. So what we want to do, we want a way to pass the result of the first query to the second query in one query using a subquery. So I've modified the query here to make it look more elegant, and it implemented a subquery. So a subquery basically is a query nested inside another query. So what I've done here, I've started with a select statement and picked out the columns from the film table, and in the where clause I've applied some conditions. So I've said where the rental rate is greater. Okay, so it will output this result first and use that result of this first query and use it for the second query. So where rental rate is greater, and then this is where the second query starts from. So this is select, and I've applied an AVG to the rental rate from the film. So the second query is nested inside the first. You can see the brackets, that's the opening brackets, and that's the closing brackets. So the query inside the bracket is what is called a subquery or an inner query. The query that contains the subquery is known as the outer query. Postgres executes the query that contains a subquery in the following sequence. First, it executes the subquery, okay, which is this query here. Second, it gets the results and then pass it to the outer query. Third, it executes the outer query. So the format in which Postgres executes, first of all, it will execute the subquery, all right, which is the inner query, the query that contains the query in the brackets. This is the bracket here. So this query here is what is known as the subquery or inner query, while this here is known as the outer query. That is the query that contains the subquery. So when the code executes, it will execute the subquery first, which is this query. And once that query is executed, it will use the result from this query and pass it on to this outer query here. And the third, then the outer query uses that result and executes it. So let me execute so you can see. All right, so this is what the output looks like. A subquery can also return 0 or more rows. So this is just a simple illustration of how to implement a subquery. You can also use other operators when you are implementing subqueries. For example, you can use the subquery with an in operator and also with an exist operator. Many thanks for watching. I hope it has been useful. Please do let me know if you have any questions. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres update statement to update existing data in a table. Let's have a look at a typical syntax. So this is what the syntax will look like to update data in a table. So you start with the update keyword, followed by the name of the table. Then you use the set keyword. This set is important because this is what activates the change. So you type in the word set, followed by the column name you're trying to make the change on. Then you use the equals to sign. This equals to basically is what you use to change the value. So after the column name, you set the new value. If you're changing more than one column, then you separate the first column with a comma, and then you do the same for the second column. If you're adding more than 2 columns, again a comma, and so on. And then you specify a where condition. The where is important. The where acts as a filter to prevent you from updating any other records in the table. So the condition you specify in the where clause is important, because that enables that only the columns that match the condition in the where clause will be updated. So let's see how this works. I've logged into the PG4 admin, and the database I'm going to use to illustrate is a database called Fruits, and it's inside the public schema. And the table I'm going to update is this table here called berries. So I'm going to right click on the berries table. One advantage of using this PG4 tool, it makes things a lot easier for you. So rather than me writing the script from scratch, I can just go here where it says script and select update, and it will begin writing some of these scripts for me. All I need to do is just make some modifications. So basically this is what it's done. It's saying this is the update statement. The public refers to the schema. Berries refers to the name of the table. So this is what I'm doing, is asking me what am I changing. So set here is what I need to specify what data I'm changing. So this indicates the name of the column. So I am going to, before you make any modification to a table, it's always best to see what the table contains first. So I'm going to do a quick select statement. Do a select star from berries. Where you've got more than one statement in the editor, it's best to highlight what you're trying to execute so that the editor doesn't get confused. That's one of the reasons you should always have a semicolon after each statement. Notice I have an error and the editor puts a dot where it thinks I've got the error. That's because I've got the name of my table wrong. So I've got a missed out an extra R. So I just type that in and I'll run the query again. All right, so this is the content of the table I'm trying to make some updates on. And when you are making update, the process is the same, whether you're making updates to one or several columns in a table. All right, say I want to make some modification to this here called strawberries. I want to change the name of the strawberry. I want to add some extra text. I just want to add strawberries and then followed by the word UK, just to indicate that the strawberries come from UK. So the way I would do that is in the set area, I will get rid of the ID because I'm not changing the ID. What I'm changing is the name. Okay, so I'm going to say set berry name. That's the name of this column. I'm going to set it, and then I need an equals to sign to indicate the new value I'm going to give it. I'm going to call it strawberries UK. So I've added the word UK next to the strawberries. If I was to do that if I didn't include this where clause here, what that will do, it will update all the strawberry, everything here will update this to strawberries UK, that to strawberries UK, and this to strawberries UK. The where clause prevents that happening. This is very important because if you're in a production environment and you have thousands of records. If you don't include the where condition, it will just update everything, and that could be disastrous. So the where clause is very important. So I've used this set keyword to indicate where I want to make the change. So I'm changing the berry name, which is this here, to Strawberries UK. In the where condition is where I need to attach the condition. So I will now say where berry underscore ID is equals to 1. So what that means, it will only change or update the records where this condition is true. You can see here the berry ID here is 1. So that means if I run this script, it will not affect the other records. So let's give that a go. I just select that and click on this to execute. If all goes well, it tells you query returned successfully. If I run this select statement again, you'll notice the change has been made. You can see now it's now updated this to Strawberries UK. So that's how you perform an update statement on a table. The process is the same whether you are updating 1 record or 1,000 records. The key thing to take away here, you must not forget to include the where clause. If you don't include the where clause in an update, the update applies to the entire column in the table. So it's very important you use the where clause to prevent errors from happening or to prevent disastrous situations. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres delete statement to delete rows of a table. So if you wanted to remove a record or a row from a table, you need to use the delete command or statement to achieve that. Let's have a look at a typical syntax for a delete statement. So this is how you would structure a statement. You start with the keyword delete, and then you use the from to indicate the name of the table, and then you add a filter with the where condition. When you're deleting records or rows from a table, if you don't use the where condition or where filter, it will wipe out everything from that table. So it's very important to use the where clause to act as a filter to protect other records in the table. So let's have a look at how we'll implement this. I've logged into my pgadmin 4 tool, and the database I'm going to use to illustrate is the fruits database. This database here, and the table is in the public schema, and the table I'm going to use is this table here called berries. So to make things a lot easier, I'm going to use the built-in script in this pgadmin to save me time. So I'm going to right click and go script. So different kind of scripts you can use here. I'm just going to say I want to delete, and it will write a delete script for me. All I need to do is make some modifications to that script. So basically it starts with the keyword delete, and then from the schema, and then the table name. This is where you specify the condition. Before you perform a delete, it's always best sometimes to check this table, what's in the table first. So I'll do select star from berries. I'm just going to highlight that and click execute so I can see the data in the table before I make any deletion. So let's say I want to delete this record here called Strawberries UK. The way I will achieve that is in the where condition. I just come here. When you're deleting, make sure you've got the right table. By using the script option from the pgadmin, it just makes things a lot easier for you. Although you can also manually write that, it just saves you time. So I'm deleting from the berries table, which belongs to the public schema. So I'm deleting where is where I specify the condition. So when you delete, you actually delete a record, a line. All these are all records. So I'm deleting where the berry underscore ID is equals to 1. That is basically the condition. If I didn't have this where clause and I just say delete from public berries, it can wipe out all the records from the table. So you can imagine if he had millions of records or thousands, he'll wipe them out. So the where clause is very important. What that means, it will only delete records that matches this criteria, where the berry ID, berry underscore ID is 1. So let's run that and we can see what it does. Execute. Tells me it's returned, so it's done the job. So if I run this again, there shouldn't be any record for strawberry. All right, so you can see it has record 1 no longer exists, where you've got berry underscore ID 1. It has removed that record from the table. So the process is the same, whether you're deleting 1 record or you're deleting 1,000 records. The key thing to take away here is that you must always use the where clause. If you do not use the where clause when you're deleting, it can cause catastrophic issues by removing records you didn't intend to remove. Very important to specify the where clause in your delete statement. That's it. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to insert new rows into a database table using the insert command. Sometimes when you create a new table in a database, it is bare, it doesn't have any data. In order to add data, you need to use the Postgres insert statement to insert data or rows of data into the table. A typical syntax to insert data or rows into a table is like this. You begin with the insert into clause, followed by the name of the table, and then in parentheses you specify the column names. If the table has got 2 columns, you specify the 2 columns, and then you add the values. The values basically is where you specify the data you're trying to insert, and the values must match the column and also in the order. So these are the columns you want to insert data or row into. You specify that first, and then in the values you have to separate each of the values by a comma. The value list must be in the same order as the column list specified after the table name, which is this one. So if I've got column 1, which is an integer, column 2, which is a string, in the value list it must correspond or must match, must be in the same order. I can't have a data type here of integer and then here I have a data type of string. It will not work. So the format, the column names and the values you enter must match. If this is an integer, the value I'm entering here must reflect that, and so on. When you're inserting or adding rows to a table, you can add 1 row at a time, or you can insert multiple values. So let's see how this works. So I've logged into my PG4 admin tool. I'm going to expand the databases. I've got 3 databases here. The database I'm going to use is the fruits database. And if I go to the schema here, within the schema, I've got a public schema, and then I've got the tables. This database has got 2 tables, oranges and berries. So I want to insert some rows, some data into the berries table. So what I can do, I'll right click where it's got berries, and then I'll click on the query tool. Okay, I can either do that, or if I want to save time, I can go to scripts and click on insert script. So that will add some of the script for me. All I need to do is make some modifications. So by doing it by the script option, it saves me a bit of time. So it has kindly done the insert for me, so I don't need to add that again. It's also added the public, which is the name of the schema, and then it's added the name of the table, which is berries. So the dot separates the table name from the schema name. And you can see the parentheses here. That's the opening parenthesis, and this is the closing parenthesis. And you see it's identified the name of my columns. Berry underscore ID is put that in there for me, and berry underscore name is put that in for me. It can't do the values because it doesn't know what values I'm trying to add. So you notice that each of the values have been separated by a comma. So all I need to do, I know that berry ID is an integer, so it must take a number. So I'll put number 1 there. If I put anything other than a number, it will not work because I'm trying to enter the wrong data type into a column that does not accept a non-integer data type. And in here, if I do the same, if I enter an integer, it will complain. So what I need to do is enter the correct data type. So I'm going to type in strawberry. And do that. Because it's a string, I need to enclose the values in quotes, and then you end that with a semicolon. Now let me execute, and hopefully it should insert the record. If I click on this here, the execute option, we should see it says query returned successful. So query returned, so it has inserted. So let's quickly check by typing in a quick select statement. So I do select star from berries. Berries is the name of the table, and I execute. Ooh, doesn't like it. Error, duplicate key. All right, that's worked. The reason I had an error is that because I didn't select this and I was trying to run the query, what it's trying to do was trying to run both queries. It was trying to run this and it was trying to run this. So it was erroring because it thinks I'm trying to add the same data I've already added. So when you have multiple scripts in the editor and you want to execute only a particular one, it's probably best to just highlight that one so the editor doesn't get confused. So as you can see now, I've got a record in our table called berries. That's the ID, that's the name. In some databases, you can set the primary key, or this column here, an ID column, you can set that to auto increase. What that means that you can set up what is known as a sequence. So each time you add a record, it automatically, increases. You don't have to manually add this column. It will auto increase for you. All right, we've learned how to insert a single record, which is what I've done here. So now we're going to insert multiple records. So again, the query is the same. The only difference here is that I've added this to, I'm inserting multiple records. So the values has to match the columns. So I've got berry ID, which is an integer column. So this is the values for that. So I add the berry ID will be this, and the berry name will be that. The second value will be 3, and this will be blueberry. I just need to change the name. I didn't change that. I just changed that to blackberries, and I'll change this to raspberries. Okay, so now if I execute this, I just highlight it. It should insert 3 extra records. Tells you there. Okay, so now I've got 3 extra records inserted. I come here, I run this select statement, I highlight it and click. You can see these are all the records. Now you can see this 1, 2, 3, 4. So that's how you insert records or data into a table. Notice that in production live databases where you have an integer column, normally that is auto populated with a sequence. So you don't necessarily have to manually add this column here. You just add a sequence, and the sequence will auto insert the next value for you. So that is it for this lecture on inserting records into a table. Thanks for watching, and bye for now. Hello and welcome to this lecture. Postgres uses comparison operators to test for equality and inequality. So in this lecture, I am going to explain some of the comparison operators that Postgres uses. So here is a table of some of the common comparison operators used in Postgres. We'll start with the very common one, which is the equals to. This here basically is used to set, if you want to check if a value is equals to something, you'll be using the equals to sign. So you're checking the condition if something matches something or is equals to something. If you want to check if something is not equals to, if a value does not match or is not equal to, if you want to check that condition, you use the not equals to sign, which is this. There are two you can use. You can either use this one, which is to which looks like an angle bracket. You use this, or you can use this one here. So either of these two symbols will achieve the same purpose for the not equals to. If you want to check if a condition, if something is greater than something, you use this. This is the greater than sign. If you want to check if something is greater than or equals to, you use this sign. This is greater than or equals to. If you need to check for a value that is less than, you use this. This is less than symbol. And if you want to check if something is less than or equals to, you use this. All right. The way I tend to remember this, if you use your left hand basically you represent less than, and for greater than you use your right hand. That's how I tend to remember them. So this here means less than or equals to. If you want to check if a value is less than or equals to, you use this symbol here. The in operator basically is used to match a value in a list. It usually is placed in between parentheses. So if you want to search for certain criteria in a list to match, you use the in operator. You use the between operator to check for a range of value. If you want to check for a range of value to check a criteria, you'll be using the between. and you specify the range, and the data or whatever you're looking for will match the value specified in that range. You can also use a like operator. Usually a like operator is used to match pattern in a column, and you use that in combination with two wildcards, the percent and the underscore. I'm just going to quickly show you a couple of examples using the comparison operators. I'm going to use our sample database, which is a DVD rental database, and I'm going to use a table or a couple of tables from this database. So these are the tables. The database has 15 tables. So I'm going to expand this table here. And the first table I'm going to use is the payment table, this table here. So let me right click on the table and select the query tool and quickly write a quick query to illustrate one of the comparison operators. This table has 6 columns. I'm going to just use all the columns rather than select specifics. So I'm going to do a select star from, and then I specify the name of the table, which is payment. Before I use any comparison operator, I just want to run this query so you can see before and after. So if I execute that, keep an eye on the bottom right here. It says 14,000, over 14,000 rows retrieved. Now I'm going to use a comparison operator inside the where clause, and that should limit the amount of records returned. So I'm going to add a where clause here as a filter, and I'm going to say where, so only records that matches the conditions in the where clause will be returned. So I'm not expecting 14,000 records to be returned. So I'm going to say where the amount, which is this column here, is greater than 999. So I'm using a comparison operator here, which is the greater than sign. So I'm saying that only one records return that matches this condition. So only where the amount is greater than 999. So I don't expect 14,000. So let me run that, and you should see a much reduced. You can see 107. It has matched the criteria I have set using the greater than sign. So you can see here, all the amounts here are above 999 because that's what I've specified. Only those that matches this amount will be returned. Although I've used a greater than sign, this is applicable to the less than, greater than or equals to, and other operators. All right, let's do one more example. I'm going to pick a different table this time. I'm going to, let's see, I'm going to pick this table here called city. It has 4 columns. So let's do a quick select on that. I'm going to do a select star from city. And let me just run that and see what we get. So we have 600 records returned for that table. So I want to reduce that. So I'm going to apply a filter. So it won't be reduced by much. So what I'm going to do, I am going to get rid of the semicolon there and add a filter. So I'm going to say where. So I'm going to say where city, this city here, this column called city, where city, I'm going to go for this one here called York. All right, so what this query will do, it will return everything apart from York. So if I run this query again, you will not see an entry for York because it will be excluded. What this symbol is, it means not or not equals to. That means return everything apart from this, where the city name is not York. So let's run that. We can see what happens. All right, so it's returned everything. It used to be 600 records, so you can see it's now showing 599, which means it has excluded York. So normally you would have seen the York now, but there is nothing, no entry for York. So that's basically how you use some of these operators. So you can, instead of using this, you can use the exclamation, and that means the same thing as that. It means not equals to. So if I look out for Abu Dhabi, if I change that to Abu Dhabi, Abu Dhabi, notice the entry here, number 3, Abu Dhabi. If I run this, I expect this query to exclude Abu Dhabi. As you can see, Abu Dhabi was number 3. You can see number 3 is being excluded from the query output. So that's basically how you use some of these comparison operators. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will show you how to use the Postgres between operator. The between operator basically is used to match a value against a range of values. The values it can match includes numbers, text, or dates. The between operator is usually included or defined within the where clause of the select statement. So this is how the syntax looks if you need to include the between operator inside your select statement. So once you've defined the select statement, you can either specify column names or you can use an asterisk. By using asterisk, that means it will retrieve all the column names. Then you specify the table name from the from field, and inside the where clause you specify the name of the column, and then you add the between operator followed by the values you want to check against. So you specify the values you want to match inside a range of values, and the data will be returned by the query. So let's go over to our PG admin tool and see how this works. So I have logged into my PG admin 4 tool, and the table I'm going to illustrate the between operator with is going to be the payment table. And this payment table here belongs to the DVD rental database, which is this database here. So I'm going to use the payment table. Before I do that, I just want to expand the table so we can take a look at the columns within the table. So I click on the plus sign and it should reveal. So these are all the columns in the table. It's got 1, 2, 3, 4, 5, 6 columns. So what I want to achieve here, I want to use the between operator to query some data. So let's open up a query tool, right click on the payment table and go query tool, and that should launch the tool. When writing select statements, it's best to avoid using the asterisk if you can. If you don't need all the data from the table, it's best not to use the asterisk, because retrieving all the data, if it's a table that's got a lot of data, retrieving that data over the network each time can slow down or can impact on the network traffic. So as much as possible, if you know the columns you need to retrieve data from, it's best to specify them rather than use the asterisk to get all the data from all the columns. So in this table here, I want to only pick a few columns here. So I'm going to select the customer ID here, customer underscore ID. I'm going to select the payment underscore ID, and I'm going to select the amount. So let me define or build a query. I do a select followed by the name of the first column, which is customer underscore ID, and you separate each of the columns from each other with a comma. And the next the next column I want is the payment ID column, which is this column here. So it's payment underscore ID, and then a comma, and I'll select the other column, which is this amount column. Next, I specify the table the data is coming from. The name of the table is called payment. So I'll type in payment. The next line is where I will specify the where clause. Inside the where clause is where I will specify the criteria or the between operator. Actually, before I do that, I'm just going to comment out this. So I'm going to comment out this where clause for now. I just want to show you something quickly. I want to execute this query as it is, so that you can see. Ooh, it says I've made an error. Okay, I had an error because I didn't comment out the where clause properly. So I've commented it out now. So you can see here that this is the data that has been returned. I have not applied any filters or used any operators here. So I just wanted you to see what the data looks like before and after I apply a filter. So these are all the rows. So let me execute that again so you can see the number of rows. So if we look at here, it tells you 1,400. This is the row 14596 row. Okay, over 14,000 rows returned. So I don't want all that. I want to filter that out. So this is where I'm going to use the between operator. And the column I am going to use is this amount column here. So you can see there are different amounts here, $7.99 in dollars, different various amounts. So I'm going to filter based on this. I'm going to set a range using the between operator based on this column here called amount. I just wanted to show you that first before including the between operator inside the where clause. So now I can remove the comment and now add the where clause. So I just need to get rid of that asterisk. So inside the where clause now is where I will include the column name, which is amount, which is this column here. And then I'll add the between operator. Notice the color has changed because it's a keyword. So then I specify the value. So I want a value between, say, 7 and 8. Notice the and is the color has changed as well because it's also a keyword. All right. Previously, when I executed this query without the where clause and without the between operator, I had over 14,000 records returned. Now that I've applied the filter with the where clause and added a range of data to return, so I've said where the amount, which is this column here, is between 7 and 8. So it will only return data that matches this criteria. So I don't expect to get 14,000 records returned. So let me execute. I'll click on that and we should see it tells me 626 rows retrieved. So that is much smaller than the previous record where I did not apply a filter or a between operator. So you can see these are the conditions here specified in the where clause using the between. So between is used to check against a range of values. So you can see here I've specified the amount between 7 and 8. So it's only return data that matches a range of 7 and 8. So if you look through the data, you would not see anything other than between 7 and 8. So you can see that all the data that's returned is within that range, 7 and 8. So that's how you use the between operator to also filter data from a table. Many thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, I'm going to show you how to use the not between operator inside your select statement. It basically works like the between operator, but in the opposite direction. So basically it is used to return values not within a range that you have specified. Like the between operators, the values can be numbers, it can be text, or it can be dates. Also, it's usually included in the where clause. So let's have a look at the syntax, which shows you how to specify the not between operator. So basically the not between operator will only return values not specified within the range of values you have defined, and it is defined inside the where clause. So let's go to our PG admin tool and have a look at how this works. So I'm going to use the payment table here. This payment table belongs to the DVD rental database. So I'm going to quickly run a query on this table so I can illustrate how the not between operator works. So let me expand the table so you can see the columns. These are all the columns within the table. So I'm going to right click on the table and click on the query tool to launch the query tool. And once the query tool is open, I'm just going to write a few statements. I'm going to select specific columns rather than use all the columns. So let me begin by typing in a select statement. So I'll start with the select keyword, followed by the columns I want to use. I want to use the customer ID column, the payment ID column, and the amount column. So I'll select the customer first, customer underscore ID, comma, and then the next will be the payment underscore ID, and I put comma, and then add the next column, which is the amount ID, amount column. So I've now got three columns: customer ID, payment ID, and amount. So you can add these columns on separate lines if you want, but I like doing it this way to make my query shorter. All right, so now I'll specify where the data is coming from. I need to indicate the table. Name of the table is called payment. Next, all right, what I want to do before I apply the where clause and the not between operator, I want to just run this query as it is so we can see. Look out on the bottom right hand corner. It will show you the amount of records returned without the where clause or the not between operator. So let me execute that. If you look here on the right, it should show. It tells you, see that 14,596 rows returned. All right, of over 14,000. So I want to reduce that amount. So to do that, I'm going to apply the where clause here. I'm going to type in where, and I'm going to use this amount column to do the filtering. Where amount, which is this column here, these values are all in dollars. So I'm going to say where the amount, and I'm going to attach the not, where the amount is not between, I'm going to specify 0 and 8. So that is a lot. So I don't expect the records to return for 14,000 or more. So I expect it to be much less, because it's only going to return values that does not match these values here. So it will exclude anything between 0 and 8. So let me execute and look at here. It says 780 rows. That's much more lower than 14,000. So I've used the not between operator to exclude data to be returned by the query. All right, so that's how you use the not between operator. You can use that to exclude a range of data that the select statement or query returns. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the like operator. The like operator basically is used to match pattern in a column. It is used to query data by using pattern matching technique. It is used with the where clause to search and match specified patterns in a column. It is also used in combination with wildcards, and the two common wildcards that are used with the like operator are the percent wildcard that allows you to match string of any length or characters including 0. So when you are using the percent in combination with the like operator, the percent sign actually represents 0, 1 or more multiple characters. So that percent can represent a 0, 1 or multiple characters including 0. The other wildcard that is used with the like operator is the underscore. The underscore actually is used to match a single character. It represents a single character. Just to recap, the like operator is used in the where clause to search for a specified pattern in a column. Let's take a look at the syntax. Syntax represents how you would structure a like operator with your queries. So this is a simple syntax whereby you select your column names if you're choosing columns. If not, you can use all the column by using an asterisk. You specify the table name, and then inside the where clause is where you, after the column, you specify the like pattern, the pattern you are trying to match. The best way to show you this is to actually see it in action. So I'm going to head over to my pgadmin tool and experiment with one of the tables in our sample database. I have logged into my pgadmin 4, and I'm going to use the DVD rental sample database. This database here, it has 15 tables. I'm just going to expand and look for the table I'm going to use. I'm going to use the customer table here. Let me expand that so you can see the columns in the table. So these are all the columns. It's got 10 columns inside the customers tables. Suppose the manager of a store asks you to find a customer that he does not remember the name exactly. He just remembers that the customer's first name begins with something like a J or Jen. How do you find the exact customer that the store manager is asking for? You may find the customer in the customer table by looking at the first name column to see if there's any value that begins with Jen. Again, this can be tedious, and depending on how large the data in the table is, it can be time consuming. The best way to search for that kind of information is to use the like operator. So let's open up the query editor, right click on the table name and click Query Tool to launch the query window. Once the query window launches, we can begin writing our queries. Give it a few minutes. All right, we're not going to use all the columns from the table. Remember, the query is basically to find a customer whose name begins with Jen, Jen. That's all the store manager can remember. Not quite sure the full name. Just all he remembers is that it begins with a Jen, Jen. So what I'm going to do is select, and I'm going to pick the first name column, a comma, followed by the last name column. And when you are specifying columns, make sure you specify the way they've been defined in the table. As you can see, my first name matches the first name here, last name matches the last name there. Next thing I need is specify the name of the table. It's called customer. And then next thing I need to do is specify the where clause. And inside the where clause, this is where I apply the condition. I specify the column first where I'm trying to search for the pattern. So it's going to be the first name, because all the manager remembers that the first name begins with something like Jen. So I'm going to specify the first name column, and then I'll introduce the like operator. I'll say like, because it's a string, I need to enclose it in quotes, and then insert a wildcard, a percentage wildcard. Actually, the percentage has to come before the ending quote. So this is how you would structure that. When you're searching for a pattern in a column, if you're searching for a pattern that begins with something, the percentage is placed at the end here of the pattern you're trying to search for. If you are searching for a pattern that ends in something, the percentage will be in front of the character pattern you're trying to search for. Because I'm searching for a first name that starts or looks like Jen, the percentage is placed at the end of the character I'm searching for. So let's give that a go and see what we get. So I'm going to click on this here to execute the query. And as you can see, we've got 3 rows from that table. And as you can see, they all begin with Jen. We've got Jennifer, we've got Jenny, and we've got Jenny. So from this data, the manager should be able to spot the customer he was trying to look for. So that's basically how you use a like operator. So you can use that to search for different types of pattern as well. If, for example, you wanted to search for someone whose first name, begins with A, again, you can change that from Jen to A, and it will search for everyone whose name begins with A. There you go. See, it searches, that's the pattern. This is everyone whose name begins with a A. Okay, so you can change that. If I move the percentage from the beginning to the end, from the end here to the front, what this is saying is that search the pattern for anyone whose first name ends with the letter A. So let me search that. So this will be searching for anyone. Oh, there's no one whose first name ends with the letter A. How about B? Let's try B. No one with a B. Okay, let's try lowercase a. Oh, yep. Okay, we've got a lowercase a. So these are people whose names end with the lowercase a. So I just wanted to give you an idea of how the like operator works in combination with a wildcard. You can also use the like operator with the underscore. When you use it with the underscore, it will search for a pattern and it only searches one character. So using an underscore will only match a single character in the pattern you are trying to match. So let's see how that works. Say for example, I want to search for a pattern in the first name that and I put in the underscore followed by her and then a %. So basically what this means is that I'm looking for a character, one character that you can add to this and it will form part of the name. So the character you add here will combine with this her to form a name of a person, the first name. So let's see how that works. Let me run that. And you can see here the pattern is returned 4. If you add C, which is a single character here, it turns this into Cheryl. So the pattern I'm trying to match is this HEROS, trying to match that with one character. As you can see, I've done that with the C, I've done that with the T, I've done that with the S, and here as well. So we just want a character, single character that will match these 3 letters, that ends in these 3 letters. As you can see here, I've done the match. So that's how you use the underscore to match a single character in a sequence. So that is it for the like operator. I do apologize, this lecture is taking a bit longer than I expected, but I hope it has made sense. Thanks for watching and bye for now. Hello and welcome to this lecture. In this lecture, I will introduce you to the Postgres NOT operator. The NOT operator is used to display a record if the condition or conditions is not true. So it only displays records where the conditions is not true. It also is defined with the where clause, so it works with the where clause. So let's have a look at the syntax. The syntax refers to how you would write such a statement to include the NOT operator. So the syntax basically is this. You use the select keyword followed by the column names. If you are not specifying the column names and you want to retrieve all the columns, so you replace the column names, just put an asterisk instead of the column names. And then in the from field, you specify the table name. And inside the where clause is where you add the NOT operator, and then you specify